introduction, I think. I don't know how much I deserve about. Anyhow, normally when we start any of our presentation like this, we just tell something about the safety conduct, which is really good because it's more of a lessons learned and the hard way what to do it about. Gopi, you can just show the first slide or.
Yeah, Tariq.
Yeah, 1 minute.
This is regarding pipeline sizing. I mean, most of you are engineers and certainly some of you are chemical and some of you from other discipline. Normally, I always look at this way, being a chemical engineer, an advantage is that we can talk to many other experts in mechanical, electrical, civil kind of, so that at least you understand that what way you can improve upon your process engineering knowledge. The safety content which I want to tell you is a live case which happened in Baroda Refinery when I was working in 83 to 86. And some of our colleagues had designed steam tracing line. All of you know that steam tracing is done in the refineries using either MP steam or MP means around 14, 15 bar, and LP steam is around 5 bar or 4.5 bar, you can say it again. So guys have done like this that for steam header, we lay a line which is around 120 feet per second kind of. So the same way they thought, okay, I can make one steam tracing also for with such a high velocity, and then they allowed the steam tracing line to be there for almost about half a kilometer. After that plant was commissioned, of course, it was unfortunately it was approved also by management. Nobody has verified it. It looks like. At that time only I landed there, and then after commissioning, they found that nothing is working. The steam tracing is not working at all, and people started questioning that what kind of engineering we have done about. Then luckily, since I had worked in Haldia Refinery and we have gone through this kind of extensive work on steam tracing, I told the people that any steam tracing line should not be more than maybe about 50 to 70 meters. The moment it crosses that, the two-phase flow, that means your one side condensation getting formed, other one is steam is trying to push the thing. So you never get what the required is effective of steam. After that, it was bifurcated into some 10 pieces, then they put some 10 more steam traps, etc., and done it about. So like that, if you start looking at it, that what you learned in the college, we all know that steam is good. It can give some heating value, or it can condense and or expand maybe around 1600 times kind of. But in reality, when you go, you'll have to keep on looking. You never get such things in your school books or text. So it's a very tough learning, and I always believe that, and that too, some of my colleagues, Rajesh is there, then NK Raju is there, and one more person he said he is from Mathura Refinery. So like that, looking at this, I'm little scared to talk to this kind of experts around. Anyway, I'll try to do my justice to exercise what I do it about. One more request is that whenever you have any questions in any of the slides, what is being presented, my request is that you can raise the hands. That is one way. Other one is you can send the chat box. I keep seeing the chat box once in a while. Something like multitasking you can say, and then and there itself I'll try to answer it rather than waiting for the end. Of course, towards the end also you can ask questions. It's not necessary that you should ask questions then and there about, but things go about. Basically, I thought that it would be more apt to talk about refinery and asset integrity rather than talking about chemical engineering purely or talking about the crude and things like that, which will be boring for most of the people. Even for chemical engineers, sometimes it really gets bored because of naphthenes and methylenes and aromatics and benzene and toluene, etc. I still remember, I don't want to name the person, in Indian Oil only it happened with Professor M.M. Sharma. It so happened that he was telling that, hey, why don't you guys do something on naphthalene? Naphthalene is two rings structure, two benzene joined together kind of. And when I was talking to some of my people, they said, no, you've not said about naphthalene, you've said about naphthenes, where there is no naphthalene in the crude oil. That's how they started about. Because unfortunately, even though we all process the crude oil day in, day out for last 30, 40 years, but some of the species of the crude oil, we may not know also. I mean, it's better to start with an assumption that I need to know a lot. Then your learning becomes easier. But the friend was repeatedly saying that he must have talked about naphthenes, not naphthalene, we do not hear properly. Then, of course, in the sincere fellow, I went to Mr. Professor M.M. Sharma again. I told him, boss, did you say naphthenes or naphthalene? He really fired me like anything. He said, Murthy, naphthalene. Naphthalene is two double bond, two ring structure. And naphthenes are what, a single ring with the structure kind of. So why are you getting confused with this about? So like that also we come across this kind of nice information, which we need to pass on to the next generation so that they don't make the same mistake like whatever we did about. And so what I thought when we talked to Mr. Sadasiv, my cousin, as well as Mr. Gopi, what is the way we can try to make a presentation which is much more meaningful to the people around, and at least ignite this thinking process. Once your thinking process is set right, and I'm sure, like I made 6 or 7 patents, and I'm sure many of you can make even 700 patents also. It's possible because God's gift is such that the moment you want some problem, you'll get some solution. In fact, I must take this opportunity to tell all of you that we did a lot of work on Six Sigma, and Mr. N.K. Raju, who is also participating in this, he did a wonderful work in terms of what way the gas turbines behave in the summer and winter, and the peak summer also between the day and night. What is the way to do it? And we were doing some work with the water automation. We do it for bringing down the temperature. So we did a lot of work in Jamnagar, and finally, thanks to Mr. Raju and his team, I should say, about, we saved one gas turbine getting failed because in the same work, same similar frame 6 machine at Azira, the people put excess water, and the water had corroded one of the thermocouple, and the thermocouple line got sheared and it went into the air compressor, and it spoiled the entire air compressor, and we lost the money. But at least in Jamnagar we did. Of course, there are always, whenever you try to do something new, you'll find that a lot of people will be against it, but be bold enough to face it, and I'm sure God shall be with us to get going on about. So looking at all these kind of issues, I thought it's to talk more about asset integrity to the best of my knowledge. Then we'll see how we can try to pursue further about. Can you go to the next slide? This is the area on which I'm going to talk about. Just to give you an overview about refinery, I don't know how many of you had the opportunity to visit refineries, and I'm sure most of the chemicals must have visited, and some people from electrical mechanic also must have worked also. But generally, I always look at this. Refinery is a place like Mecca for Muslims. Refinery is a place for chemical engineers or any engineers for the matter. Now with electronics and instrumentation becomes so vast, that's becoming another like a holy area to see it about. So it's a wonderful place to visit. And I also had an opportunity because of thanks to working with Indian Oil, we could see some of the oil well. Oil well means you can't go into the well, but you can just see in the barren land, suddenly you'll find the Christmas tree keeps popping up and saying that this is how we collect the oil and then do it. About group gathering sessions, so many things are there. Anyhow, we'll find some photographs and pictures of those areas to see it about. And that's how things, this is what I'll be discussing. And the more important is that what we can do from now on. Because I don't want to end up saying that, okay, it was more of a one-side story or we heard something different. But what is next, which all of us can contribute and make a difference to India? That's how I'm trying to put the thought process into it. So we'll see. Let's see how it is. Because always I believe in some of the great saying by some of the people. They said that ordinary people only can make extraordinary things in life. So nothing that Westerner can do or Japanese can do, Indians also can do wonderful. I put it that way, take it forward about. And some case studies also I'll be presenting during the discussions about. Next, please.
1 minute. Yeah.
This is a nutshell about what we call the black gold, and its prices varied from as low as, because when we joined Indian Oil way back in 74 or so, the price was hardly about $7 per barrel. And in between it went up to 140 whenever there is a war in there, it keep going above. And currently I'm told is around $60-65 per barrel. So it's such a huge impact on the not only national economy but international economy also has been doing it. And what is it all this about? And if you look at that, it's nothing but a bunch of hydrocarbons. Of course, millions of molecules may be there in this. And for chemistry fellows, it will be more like normal paraffins or isoparaffins or cyclopentanes or cycloparaffins, which is nothing but naphthens. And aromatics in the form of mono, ditri, etc. And all the things will be there. And it predominantly starts from C2, which is ethane. And it can be even as high as about C100, which is more of asphaltings or even wax kind of molecules you'll see it about. And with this, what we can do, that's how the challenge to the refiners. In fact, we have been, thanks to my, again, opportunity of having worked in Reliance, the Reliance has told very clearly that the bottom line is that you shall not say no to any crude. That means any crude which is given to you, where it is coming from African countries or from Venezuela or from, no, you keep the previous one only. Any crude which is coming from anywhere on the earth, you should tell me that this crude, if you asked to process, I'll be able to process this manner. It costs so much of money, and this is what the value is going to give. So if I find that delta is going to give me some good margin, normally we have a benchmark, what we call as a Singapore plus $2. That means if Singapore refineries are making, because Singapore is strategically located, because one side is Australia is there, another side you have got Asian countries which also need a lot of oil or petroleum products. And it's also close to proximity of Middle East. So that way Singapore is very well. So if you can beat Singapore, I think you guys have done a great work. So on the basis, you won't believe. In Indian Oil, we took in Mathura, for example, it took almost about you can say 83. I joined there, and sorry, 86 I was there. From 86 to maybe around 96, I would have processed in 10 years or 11 years. We would have processed around 20 groups also. Whereas in Reliance, within a matter of about 2 or 3 years, we processed almost 50 to 100 groups. So what kind of a changes are taking place? Because people say that the market is so dynamic. I don't know, I mean, how many of you are remembering about that when the electronic watch first came? Because earlier days it used to be analog watch, no? That means the needle keeps moving, and subsequently when it became a digital watch, all were available and people were able to read it very easily about. So you don't have to remember that, oh, 10, and if it is the big needle is close to 1 or 2, then you have to plot some number. But when an electronic system is much more easy, digital system is much easier to remember about. I still remember my colleague from your Honorable University only, Mr. Parniappan. He was senior to us, and he was in Indian Oil that time, Haldia. Haldia being a port city, lost a lot of what do you call it? Imports used to happen with or without knowledge of customs, etc. So it suddenly there was a big spread. Sometime in 75 or 76, you can say it about. And the price was almost about 400 rupees, 500 rupees that electronic watch was having. And those days, of course, I never had any watch because for some reason I didn't feel like having a watch also. And he came to me saying that he was working in that marine terminal area. He said, Murthy, the watch is available. Would you like to buy one? I said, I'm not interested, but anyway, tell me what is the price. He said, the price is around 400 rupees. I said, 400 rupees for a small watch is not worth it, and let me wait for some more time. He said, then he asked me, till how much time you want to wait for it? I said, let it come, maybe after 2-3 days, we'll see. After 2-3 days, the price came down to 200 rupees. Then also he came to me saying, would you like to buy now? I said, no, when it comes to 50 rupees, I'll buy. Then he said, boss, you'll never buy it at all. What I'm trying to say is that the crude price is such a volatile, and to keep an inventory saying that, yes, I have done something great buying, that becomes a big problem. That's why people do hedging, which is again a process by which they do it above. So in other words, it is a challenge not only for chemical engineers, even for the economists. It's when the crude comes, if it's not going with some species, like I maybe know that it comes with the impurities like sulfur, these are heteroatoms we call it as, all in the form of organic stuff, mercaptans or disulfides or sulfides and thiophenes and things like that. Similar case, nitrogen means in the form of amines or amides or even the form of some amino acids. So many things are there. Acidity is more with the carboxylic acids or even naphthenic acid kind of. And salt means is dissolved in the water, because salt is not soluble. The salt is what we call a sodium chloride or calcium chloride, magnesium chloride. They are not physically soluble in the crude oil, but they are associated with the water which is coming along with the crude oil. Invariably, what happens is that when you take the oil from the Mother Earth, along with this, some amount of water also keeps coming, and that water carries all these salts. So, either if you start looking at, there are several impurities which can take us to a ride. I still remember one of the fire incident took place in Jamnagar. It's happened in the VGO hydrocrating unit. I'm not sure whether Rajesh and the people were there at that time. There's a blaze, and unfortunately, we lost about two lives, if I remember correctly. It's just a drain line because the pipe carrying some VGO, vacuum gas oil, and it had a drain point which was done at the time of doing some hydro tests, etc. And all the lines normally get inspected, including the drain pipe, where a lot of stagnancy can be there about. Inspection, they do it double. And you won't believe 6 months before the inspection has given the clearance saying that yes, the plant is very good, all safe and sound, no problem. And within 6 months, there was a leak from that the boot, or the small 2-inch line which is hanging out of the main 12-inch line. And it was a big fire, and because you know very well that when the hydrogen is there, when the vacuum gas oil is there, if the fire is there, it is very tough to contain the fire, because the operating pressure is like 60, 70 bar, or maybe around, it's about 70 bar unit. So anything, and that too, the auto ignition temperature of most of the hydrocarbons start about 250. And when you're handling at 350, it's instantaneous fire. So 2 people are trying to douse the fire, but unfortunately they got engulfed and it went away. So question came that when you do the root cause analysis, what is the thing, how it happened, why is it so? And people always have a tendency, of course, with all due regards to my people who are friends in operation, they'll always say everything is fine from my end. And the other group, inspection fellow, says I did everything very well. Matter of 6 months before only, everything was certified. I can give you all the results about. Then what went wrong? Then we started looking more and deeper and find out that the corrosion which has really happened because there was some water washing done, and the water washing done with ammonium sulfate and ammonium chloride. And these two are very corrosive. Any stagnant locations, the corrosion can be plenty. So that's how it has happened, and then they last from 2 lives in the process. What I'm trying to say is that you may think that I bought the crude right and there was no problem, but suddenly you can get some surprises. If that is the case, what way we can work together to make that CSI process the crude with all confidence to think about. So in broader terms, we call it as SARA. This is a nice name given to the people, American fellows must have given. SARA stands for saturated. Saturated means both paraffins and naphthens are coming under saturated group, aromatics and resins and asphaltates. Predominantly all these heteroatoms, sulfur, nitrogen, etc., they are all in respective, but mostly they are predominantly found in the aromatics area. You'll find out. And resins are nothing but multiple rings of aromatic joined together, and asphaltates are even more bigger. If you just go by molecular weight, you can just say resins maybe around 600 molecular weight, something like that you can think about. And the molecules of asphalt maybe around 1,000 to maybe even 10,000 molecular weight can be there. So that's how the things go. As I said, the pricing of crude is decided based on the API. API is again a function of a formula, simple formula is there, 141.5 divided by specific gravity minus 130.5. It tells you if the specific gravity is 1, you can just 141.5 minus 130 is 10. If the specific gravity is 0.8, then it comes around 30, 40, whatever number it comes about. So they are sold on the prices of API, of the gravity of the crude, as well as the impurities which are present above. India unfortunately imports almost about 82% of the crude oil. We don't have the crude. They've got some crude, small crude in Bombay area, and some are in North Gujarat. South Gujarat is particularly dry, you can say it above, and some parts in Assam, and some are in Godavari basin. So like that, you have got only about maybe around 20-25 million tons of crude. No, around 30-35 million tons of crude what you are producing now. Of course, one more is in Rajasthan. This is the Balmer area. This is the train to Mangla crude, we call it as. But by and large, if you had to buy 82% of the crude, so India imports 82 means almost about 4 million barrels of crude per day. 4 million barrels of crude means is equal to, even if it takes $60 per barrel, so 4 million into 60 is around $240 million of crude I'm buying every day in, day out. That's how the things go about. And the crude oil well can be even as deep as 15 kilometers or even as shallow as 240 feet. Anyone can, it's like any well. Normally, if you go to Bangalore, I don't know how many of you are from Bangalore area, people say they go to even 1,000 feet to get the water. You can just see even at 240 feet, if I'm getting oil, I think you will be the richest guys forever. And India, as such, today it has got around 23 oil refineries, and some more are coming up. One in, what is that place? Again, Rajasthan is coming up, Bombay refinery talking about. Another one is West Coast refinery, which is supposed to come in Ratnagiri area, they talk about. There again, location and so many things are coming. And there are some expansion taking place at NRL as well as in Cochin, in Chennai, there's CPCL, that Narimanam refinery. There they are trying to scrap the old one and put a new one. So currently it's around 5.1 million barrels per day capacity of the refinery. And whereas Americans are consuming almost 11 million barrels per day. That means Indian consumption of crude oil for the whole 1.4 billion people as compared to Americans of maybe 0.3 or 0.4 billion people. You can just see the Americans are consuming almost more than twice the Indians' capability. That's a kind of magnitude we can think about. That we see, Americans are consuming today means that somebody has put a lot of efforts to make it happen. Unfortunately, that is where we'll have to start thinking that who is holding me from making it happen? Is it that I'm having for my own ego, I'm not allowing certain things to happen, or can we do select collectively to think about it? And to that extent, I find this forum of viewers can make a difference. Once we put our heads together, and yes, together we'll be like Ubuntu, what the people call about that instead of me alone getting the benefits, let my society get it or let my friends get it together. That's the greatest achievement we can think through. And another good thing is that, thanks to Reliance, of course, it has got the largest capacity in the refinery in India today. Not only India, is the whole world. There are about top 10 refineries, and Reliance is the one which is 1.4. And the nearest next is, I think, if I remember correctly, in SK Corporation, which is South Korea. South Korea is around 0.9 or so. Then after, you've got many other refineries around 0.7, 0.6, etc. So we can be proud to say that, yes, India has got the biggest refinery in the whole world. That's how we can think through. Okay. I'll go to the next one. Sorry, one more point is that there's oil to production ratio, we call this. There is item number 8, what you're saying it. When we joined Indian Oil way back in '74, people are saying that oil will last not more than 25 years, and after that, you have to find a new work to think about. Then we were just calculating, okay, our age is already 25 that time when we joined, so 25 is maybe 50 years. Our life will be okay when we think for our children what is the way to think about. But now the current oil to reserves to production ratio, if you look at it, the oil is available for another 50 years. So you can probably tell your children saying that nothing to worry about. This oil industry will survive for another 50, 60, or maybe even 100 years. And we'll have to start looking at what is the way by which I can effectively or efficiently I can use my oil reserves. That's more important. I mean, today, if my IC engine is giving around 40% efficiency, can I make it with around 80%? What is that which I need to do to make it happen? How do I get it about? Or I try to work in such a way that unwanted load in the IC engines. The car with 1% going and with 10%, 5% going, it has got its own. You have to start thinking in a different way. Can I make a difference? How do I get the efficiency to maybe as close as 80 or 70, whatever number we can think about? So these are some of the new thinking can come. Then we start working even more deeper about it. Okay, go to the next one.
1 minute.
Hello.
Yes, sir.
I
Can
think
you?
some.
Yeah, I
you're,
think.
you're, you're muted your speaker. Hello.
Can you hear me?
You can ask the question.
Can you hear us? Sir, can you hear us? Your voice is not audible. Sir, your audio is not connected, sir. Gopi's audio is, yeah, now you are connected. Can you unmute yourself? Yeah, can you please try now? Gopi, can you please pick up? Hello, Gopi. Hello. Hello.
ஹலோ
வைத்தி உங்களுக்கு சவுண்ட் வருது சார் இது
வருது சார், சவுண்ட் வருது சார்,
எனக்கு வரல.
வருது சவுண்ட் வருது. கேக்குதா சார்?
இல்லை வைத்தி,
வருது சார், சவுண்ட் வருது. அவர் பேசுறது வருது.
எனக்கு வரவே இல்லை ஒன்றும், ஏன்னு தெரியல. இது என்ன பண்றது? I'm not able to hear anything from him.
நீங்க பேசுறது கேக்குது, உங்க மைக் மியூட் ஆகல.
'60s, we seldom have sulfur plant in the refinery. But nowadays, no refinery is, at least to my knowledge, available. Maybe except one or two probably. Not having sulfur plant in the refinery, because all the sulfur in the crude, we try to take it out and then go into the as a form of production of sulfur. So go to the next point. Next slide, please. These are all some of the Bible, what we say that we should follow in our refinery. What it says is that given any crude, we should be able to process with confidence. See, like for example, no, I mean, somebody runs the what do you call them, car. Touch wood, I mean, he has been traveling maybe lakh or million of kilometers, but he has never met with any accident. As one thing is really happened, but he knows what is the care he is taking it about, when to speed up or when to come down or when to anticipate kind of. I mean, there is a continuous some kind of a proactive and a reactive mechanism works in the brain to make it happen. Similarly, in the crude oil also when you process, you need to have the confidence to say, yes, I can process the crude and this crude will fetch me so much money. That's kind of a confidence engineers have to build together with the rest of the colleagues. It's not only chemical engineers, it's a mechanical, electrical, civil, all fellows put together. And we call it as one crude for opportunity crude. Opportunity crude, the name has been given that way to say that, because nowadays what people say, no, any adversity, you turn it into an opportunity. That means what you call it as a gap or problem, these are all some opportunity for it to solve and get the best value out of it. That's how the names have been given as opportunity crudes. Typically, opportunity crudes have got API, that is a density, which is less than maybe around 20 to 24 like that. And sulfur maybe around more than 3-4% kind of. Nitrogen will be also pretty high, almost about 2,000, 3,000 ppm. Most of the crudes coming from Venezuela or Brazil or Colombia, etc., they are all coming to the category of this opportunity crudes. Or even in Canada now tar sand crudes are available. They are also coming into the category of this opportunity crude. Most Middle East crudes, they are common the crudes of. It's not a big brainer saying that anybody says that I can process Middle East crude. It's fair enough. But crudes coming from Chad, which is the African crude, is a sweet crude, but it has got more of a what they call the calcium naphthenate, which is again a notorious element when it interferes our desalting process. So like that, we have got several crudes. We call this as the opportunity. As the crude oil moves from far west to east, you'll find the crude is becoming more and more sweeter. Most Indian crudes are sweet because sulfur is less than 0.5 or 0.3%. You go to Malaysia, the Tapis crude is much more sweeter. It's hardly 0.1 sulfur. You go to Indonesia, again the same. And you go to Australia, the crudes are practically not with any sulfur, maybe up to 0.5 or 0.05 kind of. So that's how the world has been saying. I mean, all tough crudes are there in the West, and some are in Middle African countries. And when it comes to Middle East, it's fair enough. There is mid-range, you can call it. But the moment it comes to India and down below, we'll all sweet crude, we call it as well. Sweet crude always fetches more money and it produces more gasoline or more naphtha. So unless some demand is there, there's no point buying the sweet crude. That's why we'll look at it that way. Second thing is that I told you that we always need to have the refining margin, which is nothing but the crude at which I buy, then all the products what I make. Because if I process 100 tons of crude, invariably you'll get about 90-95% tons of the products, and the balance 5% is what we call the own fuel and loss. Some amount of energy is needed for making the refinery run. So for which we take from the crude itself. We don't buy separately fuel oil or fuel gas from outside. Then you have some losses will be there in terms of transit and oil evaporation, so many things. Because always oil hydrocarbons are highly evaporative also, like naphtha or gasoline can just evaporate if you leave it in the atmosphere forever. So looking at that, what is that barrel I'm getting in terms of dollars? There is a delta. It means it's not having any other operating costs like manpower costs or chemical costs or your maintenance costs, etc. It's sheerly the product value minus the crude price divided by the crude. And that we always should get around 10 plus. If a refinery is good, refinery is running means they should get, either I reduce my incoming crude cost or I increase my product value. If I make more of, let's say, aviation turbine fuel, you get more money because aviation turbine fuel, which is of course not today. Today there's a big glut because of the COVID situation. Otherwise, aviation turbine fuel is always get about $15 to $20 per barrel. When there is a war, you need aviation turbine fuel for fighting the war. So then the prices of aviation turbine fuel go up. And diesel is again another good thing, which gets about something like $12 per barrel. And gasoline is also equally a similar one. But there are some products being sold below the crude price, like bitumen or like fuel oil or sulfur. These are all being sold below the crude price. Now, the job of refiners is to see that what is the way by which I can even convert some of the products which are going below the crude price. Can I make it better than the crude price? Here, I just want to give one small digression. In Reliance, we had, of course, in all the refineries, we have what is called the Merox unit. Merox unit stands for mercaptan oxidation. What it does is mercaptans are highly corrosive nature, which is there in the LPG, and we need to convert it into disulfide and then take out this material so that sulfur can be reduced in the LPG being sold to the market. It's Indian or HPC, HP gas or BPC gas and things like that. Now, when you're doing it, they make what is called disulfide oil. This disulfide oil is nothing but predominantly either it's dimethyl disulfide or methyl ether disulfide or dipropyl disulfide. Like that, there's a mixture of several things come over. When this coming, and then after we take it to hydrotate and gets H2S. When H2S goes to sulfur plant and we produce sulfur, again to be sold to the market at $30 or $40 per ton, whereas the crude price is around $450 to $500 per ton. Now the question came that can I do something with this disulfide oil? Can I make this use of it in a better way? At that time only, when I was in Reliance, we had taken over this IPCL people. I keep the previous slide only. We had taken over the IPCL, and the IPCL folks said that yes, we can try to look at what way we can try to have some synergy out of it. My boss, what tough jobs will be given to people like me and Raju, so that's how we called us. And he said, boss, why don't you do something for this? And I told our IPCL R&D friends, when Chaudhary was there, Dr. Chaudhary was there, I told him, boss, this is one stream, can you do something out of it? And he said, you give me the sample of the stream and give it. So we gave, it's disulfide oil is very like a rotten, smell of this garlic. If garlic gets spoiled, what kind of smell? It's very pungent smell. Even taking the sample is a big task. And anyhow, we gave 2 liters of it to it and tell him to do it again. And you won't believe, we found out that this is as good as dimethyl disulfide, which we are buying at $3,500 per ton. Imagine the price, which is I'm getting hardly about $30, and that too after different processing. And he is able to make the same thing equivalent to DMD, dimethyl disulfide, which is around $3,500. That's just a small, we produce hardly about 1 or 2 meters per hour. And finally, that became a patent, and then one more feather in our cap, Reliance cap. Then when we wanted to use it for some of the hydrotators, the point came that it comes with some caustic, 2 to 3 ppm caustic will be there. We talked to many people, including UOP, Shell, everybody. They said, no, nothing, you can't do anything better than that. It's very tough. Of course, thanks to some of my friends in R&D at Jamnagar, we found out one adjorbent, Engelhard, I think Engelhard, Johnson, if I remember correctly. We bought, and then they said, why don't you try it? Then we did lab experiments, and finally that became another patent. What I'm trying to say is that never think that any species which is God has created, it has to have some value. So one thing is we need to probe our mind to find out what is the value I can get out of this. Similarly, there is one more stream available in which we have tried so far, we could not succeed over. It's called 2,6-DMN, that is 2,6-dimethyl naphthalene. And this stream is available plenty in our life cycle oil, which is going into the diesel pool. this stream, if you're able to take it out, this has got about $10,000 per ton. That's the price what the people are buying it for, using as a plasticizer. Now in LP, when it goes into diesel, first of all, it spoils the diesel. And second thing is that it fetches hardly about $600 per or $700 per ton. Look at this margin. Maybe if you go into the molecular area, isoprene, leather, these are some of the things too, unusually high cost material, which is available in the refinery. We don't know what value they are using it about. So we have to start thinking that what is the way I can create value out of this. Next point is that safety integrated operating window. We did this technology, this methodology came from Shell. The idea is that am I operating my plant safe way so that there is no untoward incident about. So these are some of the things we start looking at it in a very critical manner. Of course, more from now with the water coming up, no one shall use the groundwater, which is again an important thing. So if refinery is consuming some groundwater, start looking at what is the way I can minimize the groundwater use or eliminate it. So this is what we call as the zero liquid discharge. Now, many refineries are following this kind of a concept of it. So basically, bottom line is that thanks to again Six Sigma learning which has been given, you have to start probing that what I can do tomorrow. Rather than just take a routine work, we'll keep on giving to either operation guys will do or maintenance guys will do. But as a technical support team or as the people who are capable of thinking, start thinking what I can do so that I can create value to the company. Similar is the case with the fouling and so many things are there in the system. Go to the next one. So this is some of the things what we are seeing. Some of the practices what we follow in the refineries today. If you look at this, certainly refineries are much more, what should I say, well organized and trying to say that yes, we can make a difference. And another good thing in refineries are that we share our information with in some of the forums, be it in Center for High Technology or be it in some of the AFPM, American Fuels and Petrochemical Forum. When we share, some people will say that these are things we have done. Then automatically people who are coming up, they have got a curiosity to know how did you do it and what way we can improve upon. And again, we do involve some of the consulting work either with Shell or UOP or Chevron or Exxon and trying to keep on saying that what is the way to improve upon. The best part is that when the refineries are integrated with petrochemicals, petrochemical flows are supposed to be highly pure flows because we talk in terms of purity, 99.9 or 99.95 and things like that. Refinery flows are crude, guys. We talk in percentages. You don't bother about this kind of purity about. But this combination really makes you think better. One of the things which came in the when the Reliance Jamnagar refinery started, there was a big quarrel or fight between the petrochemical fellows and us. They were wanting certain species in the petrochemical naphtha waste goods. We told boss, we talk in terms of distillation. You tell me what is the distillation you want, whether you want 30 IBP or 40 IBP or 50 IBP, we can do it about. But if in terms of species, if you want, no one can do it about because what are the crude I buy? The crude is not bought just for your species. About that used to be quarrel, but finally we found out which are the naphtha which is being made in the company with around 7 or 8 cents and which naphtha has got more value to them. And we started segregating and made them so they're also happy and they're also happy. Invariably, what I'm trying to say is that look at the streams which are produced in the refinery, look at what it contains. Nowadays, the lab support, NAR or NMR, anything is available on the earth, whatever you name it about. Now, question is that what is the way we can try to look at it? What process can help us to work on it? That's what it's saying about. We do data analytics, we do incident analysis, we do RCA or root cause analysis of what you name it on earth. Everything is being done by the refinery. This is a great use. I mean, and not just because I am also doing, but they're creating value out of it. That's how I look at it. Okay. I'll go to the next one. These are some of the best practices, and particularly when Jamnagar refinery came up, the second refinery, there was a problem came by this that some exchanges which were made from Godrej, unfortunately, started failing in some of the pressure testing. So we were trying to find out why it is happening and what has gone wrong about. And finally, we found that the reason what was happening was some information which originally was there in the process data sheet was not available in the final fellow who is going for fabrication purpose. So when this was removed, then the 10/13 formula and so many things came about, and then finally we could solve it. But what I'm trying to say is that the process guy, the fellow who is designing the first, making the process data sheet, he knows that this exchanger is supposed to operate shutdown condition or shut up condition or in different operating modes. Sometimes it may be running on diesel mode or sometimes on LPG, whatever maybe, I don't know. In FCC, they have diesel mode, gasoline mode, LPG mode, or propylene mode kind of. So like that, people have to start looking at which are the modes in which the plant is, the equipment is supposed to be getting subjected to, and then design for the worst case scenario. And sometimes you will have wet H2S because if that is not done properly, you may end up in some corrosion or some fatigue reasons. So these are some of the things keep coming about. And we were doing a regularly P&ID review. That is once in the 5 years or so, because the P&ID once is made, not that it's made forever and it's like a static, not so. Some small modification people will do it, and if that may not getting updated, then again you might up in problem. So these are some of the good thought process people do it to make it sure that yes, what refineries are running at its best. If you ask me, compared to many industries, refiners throughout the world, they are really doing much better. Even though we call now in the form of, even within them, we call it the first quartile guys, second quartile guys, third, fourth. The fourth quartile guys means they are to do a lot of improvements. First quartile guys means they are trendsetters or pace setters kind of. You'll still find a difference, but if you ask even the fourth quartile fellow, it may be better than the steel fellow because of the information which is available, sharing for him, how he is getting the best thing out of it. And naturally, part of exercise is that we do Solomon benchmarking. There's one slide available. Gopi, can you show that Solomon benchmarking, that one file which I sent you? No, not Excel sheet, that one more PDF file. Yeah, this is just an illustration about how Solomon does the benchmarking and then doing it about. I mean, it's available in the net, and whoever wants, they can just see it about. The idea is that reliability and maintenance aspects are becoming more critical. So even 1 day saving for the refineries, if I do, you straight away multiply by whatever crude processing capacity, multiply by $10. That's kind of a money comes. For India, India is at 5.1 million barrels per day. If India can process the crude for 1 more day, instead of having shutdown or reduce the shutdown time kind of, you get about $50 million per day you gain. It's a huge amount. So it's not a simple thing to think about. That's one thing. And second thing is that when we do some work, what is the way we try to prioritize? Because everybody has got idea, fair enough. Now, which is the one we should take it to the first? Gopi, you can put the Excel sheet just to give the glimpse of it. I hope you can see it, because this we were using for prioritizing the thing based on certain concept like 139. Because many times what happens is that if I use that, ask somebody to give the ranking, whether it is 4 or 5 or 5 or 6 or 6 or 7, people will always get confused and they'll say, oh, this one is known to me, so you give him more mark. Or this one is not known to me, so you give him less money. But here what happens is that you have to give only three numbers, 1, 3, 9. 1 means there is no influence at all, 3 means it's very moderate, and 9 means there's got maximum influence. That's a very straightforward, which is Six Sigma language, what the GS taught us about. And then there are several categories, whether it has got any impact on environment, whether it has got something to do with energy, or it is going to be capital intensive, or it can be doable. I mean, how you feel in your brain, in your thinking process. That so like that, you could do some multiplication factor and some one simple formula is there, by which what we can do is that we can get it quickly. That okay, these are some 10 or 15 ideas I'm having. I would like to take this on priority basis to do it. It's a simple thing what we have been following. It very effectively we have found that is it really helps the management also saying that yes, it makes sense for me to do it about. So that way, that's the smart way of doing it. This is a culmination of some 2 or 3 ideas we brought together, and finally we made this as a standard for Reliance. So anyhow, I hope Reliance is not going to question me, but nevertheless, you can just see it about. The UOP gave some way when they did the profit improvement opportunity program. Shell gave us something, and GE gave something else. So finally, we found that looking at all the 3, this seems to be much better. So now this is being practiced in Reliance for all the prioritizing work about. Okay, now go back to the presentation. So you can see that the gap analysis, this is how we look at when you do the benchmarking, you know what is the thing happening about the mechanical availability. 97.9 is supposed to be the best. That means hardly 2% of the time. That means only 7 days in a year, a unit can be shut down for whatever reason. It may be because of some power failure, or maybe some partial failure, or some incident took place, or some compressor problem, etc. But otherwise, I'm supposed to get the availability as high as 98%. and some of the worst fellows are doing 94. 94 is also not a bad thing, but he's still part of the pace 4. I mean, pace setter, from pace setter, he's distinguished put as the 4th quartile. And same is the case with the maintenance cost efficiency index. This talks about PRE. PRE stands for plant replacement value. I mean, if I buy a plant for $50 million, and every year I should not spend more than 1% of it as a maintenance cost. This is another benchmark Solomon had done. It's really a good way to think about. You can see the difference. No, one flow is 1.09, another flow is 1.199. I mean, between 1% and 2% is a huge money which comes in terms of overall when you start multiplying from multi-refineries abroad. On-stream factor is another one without slowdown, 95%, 85%. There are several gadgets we use in terms of what you call. I mean, FSM is called field designation module because it tells you about online corrosion which is happening about. Same is the case with PermaSense, which is also talking about things, and degradation mechanism. We have a list of almost about 35 degradation mechanisms that can happen in the refinery. The idea is that, see, this helps the new joinee very well, saying that what kind of things can go wrong in my refinery, where I'm supposed to operate, or the unit which I'm supposed to operate, how I'm going to protect myself. So that's how it comes about. And we also conduct what is called joint industry program with Shell or Honeywell UOP, or even with Exxon, etc., with some universities in US. Idea is that some issues which are coming up, what is the way I can do a better prediction of it? So that way things work together. Okay, go to next one. This is just an illustration about what is the mechanical availability and where the industry leaders are there and where the poor fellows are there. I mean, you have to migrate to the top left corner. That means both mechanical availability should be at its highest and operating costs, so there is maintenance cost should be at the lowest. That's how it works. PRU, as I said, is the plant replacement value. Not more than 1% or 1.1% is the one what you should use it about. And well, I mean, see, so now with the computer computation is available so easily and cheap, we should start looking more of a measurement by which I can make a control. That's what it says in this. RAM stands for reliability and and maintenance. There's nothing on the basis. Reliability action and maintenance, something like that. Solomon benchmarking. Yeah, next please. These are some of the list of what we I talked to several people in XMEL, Reliance, and IOC, DPCL, etc. I mean, I listed because I don't want to put anything from my own idea to think about. What are the top? Maybe of course, maybe more, but even then I just took it as a top 12. If we can do something on this as a team or get some solution for it, that's a greatest achievement we can think about. Slop, like that's what I was talking to Gopi, being a mass transfer guy working in the Sulzer. He is making a lot of packing or trays and things like that. But still, what is it which is missing in us to look at that slop price back? What happens is that this is in the vacuum column. It's in the most about the flash zone we call it as the vapor, the first vapor zone you can think about. The temperatures can be even as high as about maybe 380, 300, 400 near the region. And there is something called entrainment, because see, normally when we say that even when you boil the water, if the water is boiled faster, then what happens? Some amount of spread of water gets into the vapor phase. It's like an aerosol, no? It just comes up. And similarly, if any aerosol of crude oil, which is predominantly asphaltene, which is like a coke, if that comes, what is the way I can capitalize? So we have something called wetting velocity and C factor. We do it on a regular basis. But see, you're not there 24 hours, 24 by 7. Night shift, something goes wrong. If the measurement is not available to the operator, poor fellow will not go up because all people are not capable like what others are supposed to be. But in such cases, what is the way I can make a system so that he is operating in a better way? That means we start looking at what are the handles the operator should understand. And second thing is what kind of issues that can happen. Unfortunately, the first one is still in the dreams to us. Many refineries have been trying, because once by mistake we went in for structured packing, thinking that will make a difference, because there's a fight between the reliability and the product fractionation efficiency. We want to make more and more better fractions so that improve the efficiency or improve the yield of certain commodity. And on the other side, you'll find that energy is pretty expensive. That's one thing, and the reliability is also equally important. Higher the efficiency I'm trying to attain, then there is a chance that you may end up in poorer reliability, and there's no point saying that I achieve one day. The plant should run for at least 6 years. Nowadays, people talk about 6 years of run length between any turnaround. So how I'm going to get it up? And second point, which the Reliance people wanted to know about, is that they are using glucose stainless steel in some of the direct effluent air polluter. And here the problem comes more from ammonium bisulfite or ammonium chloride corrosion or any other corrosion which they are not, at least I have not come across so far. We have to start looking at, see, that's why, with all due regards to the good knowledge we got from Mr. Mukesh Ambani when we worked with him, he told one thing very clearly: look at what did he do in the laboratory here or in the R&D scale. If your efficiency in R&D scale is 100%, then the plant is showing something like 80 or 90, then you start looking at what is the gap. For example, if easier said in a very simple way, that is, I'm using some chemical and I know that with 1 gram, I can achieve that requirement. Whereas the plant is asking for some 4 grams. That means your excess, I'm putting it above. This is what he calls a zero-based approach. The zero-based approach tells you that what is the efficiency or effectiveness I'm able to achieve in the R&D or lab scale. Am I getting in the commercial, which is scale up? Whereas what I do it in the lab or pilot plant, which is around 2 liters per hour, and I'm processing around 2,000 tons per hour rate, there will be some amount of degradation of the efficiency taken place, which spoils your either your money or in terms of fractionation or loss of throughput, and so many things can happen. You start looking at this gap. Can I do the scale up in such a way that I got the best of what I got in lab way? So maybe we'll have to start looking. That's why yesterday I was talking to Gopian people. Overhead system on CDU. This also there, item number 6. We'll invariably find that most of the refiners, we have done wonderful, they thought, but the overhead corrosion used to happen. Within 3-4 years, we used to change the exchanger and so many things happen. Now we'll have to start looking at, like in our IC engines, like diesel. In those days, you have an automation install about 70 or 80 bar, but nowadays around 2000 bar material is available when they went in for the Euro 4 or Euro 6 kind of emission norms we are trying to do. Maybe you try to automate and trying to pulverize the the particles which are coming out. So maybe we'll have to start looking more from a particle technology or particle way of chemistry, or in an automized manner, to see that what is really going wrong about. Because one of the biggest setback we had in, of course, in GE when we worked, we thought the low salt chemistry means that is sorting will take place only after the water dew point takes place. The water is always available for the salt to get out of the system. But unfortunately, it never happens in reality. Some moment of some pockets and corners, you'll find salt has taken place, and these salts are much more corrosive than the ammonium chloride. And we ended up in some kind of perforations in the overhead lines, and so many things took place. There's a real fiasco you can think about. Because general corrosion is one thing which at least you are able to anticipate and do it. But when the corrosion takes place in this product manner, or when it is in the form of pitting corrosion, because we did talk to, there are many corrosion experts, is there any way by which we can control the pitting corrosion? The answer is still today 0. Maybe we'll have to start thinking that is there any IoT which can capitalize some of this, and or that CFD, a kind of a thing wherein I can predict what is happening in the system to go through it. And there are many other things like on-stream factor for the PET gasifiers. It's supposed to run for almost about 180 days or 200 days before any maintenance is called for. But nowadays people are struggling to get anything more than 120 days. So what is it this is happening about? What way we can try to do? That means in all these exercises, one thing is coming very clear. One is about the knowledge about the materials, or the knowledge about the measurements, or knowledge about the control systems. And beyond that, the knowledge about the chemistry, which is deep lying, which is very critical. If anything of this kind is fundamental knowledge is missing, then we end up in all this kind of a chaos. Because unfortunately, the chemistry guys, we always try to hoodwink. Like, for example, the water. The water has got calcium chloride is there, magnesium chloride is there, sulfate is there, but everything reported in the form of calcium carbonate, because they found it much easier to express. Like crude oil, we have got density, but why the one more API has been given? Because they found it very convenient to use it that way. This way, when you start writing it, and sometimes the people get missed out whether they're talking about calcium sulfide or calcium sulfate. So these are some of the things you have to go more deeper. Can it form in the environment in which I'm operating about? So some kind of a thought process on this to go about, to understand how we can do it about. And same is the case with cookdrum, because the thermal cycling is taken place, because sometimes the temperature is maybe around 60, 70 degrees when I'm doing the coke cutting. And sometimes the temperature even goes as 500. That means you can imagine within 24 hours, if the cycle has to be repeated like this, in the first 24 hours I heat it up, and second 24 hours I'm cooling it down. It becomes a big task. I mean, no amount of metallurgy can withstand. So what are the way we can try to do? Is there any better way we can think about? Somebody start thinking, because people have been changing the coke drum after about 15 years or 10 years, where it's supposed to run for 50 years. What is the way to take it forward? Well, when I said that maintenance replacement cost percentage should be 1%, That means 100 years is the life what the people are talking about. If I bought something for 100 rupees, if I'm supposed to spend only 1 rupee for maintenance, that means I'm supposed to run the unit for 100 years. Then only I get the value. If I'm spending 2 or 3 or 4%, that means my life is falling down automatically. That way you look at it. And another one is in this efficiency. I mean, the form of more the throughput I push, item per time. No? We do get a lot of high pressure problem in our HP loop. There is high pressure loop in the hydrotreaters and hydrocrackers. What is the way we can try to improve upon? Because the moment I take out, avoid some two-phase flow, I end up in some fouling or some cracking and things like that. Is there any better methodology available or better way I can try to overcome? So we'll have to start thinking in those issues of it. Another one which repeatedly almost 3-4 refiners have done that where the rains are plenty. People are saying that corrosion and insulation is also one of the critical one. Is there any way by which we can start predicting or doing or using some drones to take care of it? I don't know what kind of things can come about. By and large, what I'm trying to say is that there are areas where people can do wonders, and I'm sure people like you can make a difference. So, nothing harm in failing. I'll always look at the faith that we tried our best and we could not succeed, but maybe somebody else can take it from you and then achieve it. That's also the greatest achievement. No? Like I don't know, Einstein or Thomas Edison said, no? When he found the electrical bulb after about 100 trials, he said 99 times I know how it not work. Take it that way to work with it. Next slide. There are some of the barriers and enablers you get about because there are some people who can help you, and because like in Six Sigma again we call it as a PTC. PTC stands for anything you want to do something different. Some people can oppose you or support you politically. Some people can support you or oppose you technically, and some people can support you or oppose you on a cultural basis. These are some of the lists which is coming in the form of more of a technical issues which is coming. What will we try to overcome? So if you look at this, certainly as individuals, Indians are capable and highly knowledgeable kind of. But when it comes to collective, something is going wrong. I don't know. I mean, I'm sorry to say it about because I worked in private, public, and private, and multinational. I find that Indians are Indians everywhere. When there is a crisis, we all come up like anything. But when there is no crisis, they keep on creating crisis. That's how I look at it in a very nutshell. And, of course, in particularly in public sector, I'm saying that the management time is wasted because some MP will say that he wants to visit the refinery, or MLA will come and say, I want to visit the refinery. The management time is lost. But in private companies, I have never seen the top man of the company run around some of the people. There are people they will take care of him without even knowing his knowledge of it. Maybe we'll have to start looking at the processes, how we can, because some of you are entrepreneurs and you have your own skill or you have your own passion area to make some solve the problem. But if your time is 24 hours is disturbed by all these unwanted issues, then there is a big problem. So you have to find out how you want to allocate your time, resources, and get going again. So these are some of the things I thought I'd just tell about. And you can read, and I don't think anything else is there to talk much on this. But certainly a multidisciplinary approach, like what we do in some of that root cause analysis or trying to improve upon, we'll find amazing difference. Because many times I'm seeing that some of the questions put forward by instrument guys. I still remember one of the very good, hard learning I'd call it as about. I thought because when I was a process engineer in in Indian Oil Haldia Refinery, there was need for us to put some control valve. So I went through some of the because never control valve sizing was not taught at least in my college days, but now I'm not sure whether they're touching or not. What is CV? What is pressure drop? What is the flow and all kind of what is the temperature? I mean, whatever chemical engineer way of looking at it, we gave. I thought I have done a great work and I gave it to my friend, one Mr. Venkatachalam. He was also from MIT. There is Madras Institute of Chromepet. He was in engineering services. He was instrument guy, engineering services. I told him, boss, I mean, this is what one control system is needed for from water line or something like that. And can you help me to buy a control valve and we'll put it in our scheme and give it away? Because the process engineer is supposed to make the scheme. And all the critical ones, he should give some data sheet also to do it away. And those days there was no standard data sheet. Either we had some linkages with EAL, etc. So we wrote on our own and gave it in. Then he said, Murthy, this is the dustbin, I'm putting it in there. I was really taken aback. What the hell this fellow is doing like this? Because first of all, culturally, that fellow is a Tamil fellow. I'm also speaking Tamil. At least you should have supported. That is one thing. And second thing is that at least being an engineer, he also should have supported the engineering fraternity. Politically, there's nothing that because those days there is nothing called Congress, BJP, nothing else to think about. We were in a different world altogether, and a place where Haldia means is far away from Tamil Nadu. So I was a little taken aback, and I felt, why do you say so? And he said, boss, don't worry about it. It's not that I got anything against you. But certainly we need to do a lot of efforts on this. And he gave me one Macedonian book, Macedonian control valve book. Then on the basis we started reading. Then he says that what is shut-off pressure, what is the minimum and maximum flow, what is that? Then he says that unless I get all the things, and also he says that you have to write your vapor pressure of the fluid, what is happening. But then it can become a cavitation that can happen on. Like that we started looking for. That means as a chemical engineer, you learn a lot from the other discipline people, which is again a greatest achievement. When God has been kind to us, I'll put it that way. So that's why you start looking at the material approach is really good for you to get the things going. But certainly we need to own the problem. That is more important, because if I don't own the problem, you don't get anything. Because like what I told you, N.K. Raju did that work on that dehumidification or humidification of our air, which is going to the air compressor and gas turbine. If we started owning the problem, he's saying that yes, come what, we talk to GE fellows, we talk to many other fellows, we do it. And many people will keep on saying that no, this is not possible, over. That kind of a negative attitude. There are people, of course, but once you believe that yes, I will make a difference. I'm very happy that when that Hazira fellows failed and we succeeded, it's really, of course, not that we enjoy that others failed, but it is people started thinking that yes, the 6 MI has got a way to do it. It's a painstaking effort, but certainly it's a good to think about. Okay, good, next. This is some of the things to excite you. I'll put it about, and you can just see that because the question will come, what is the size of the pie? We call it as one famous line which Chevron uses about. I think any problem, if I'm able to find some solution, what is the merit I'm going to get? What is that incentive I'm going to get it? Not as an individual, but as a company or whatever. We call it the size of the pie. It means how big the size is the problem about. If the problem is solved in one refinery, if I'm able to replicate in 600 plus refineries, you can imagine what even if I take, let's say, 10 lakhs from one refinery, 600 refineries getting the same solution, you can say almost about you have made 60 crores straight away. That's how the things work about. And another most important is that if I'm able to process the opportunity groups, which I said, you remember the beginning I said that 70% of the growth should be opportunity growth. That means because depending on the market, because if you go to market today, there will be a lowest crude price maybe around $50 or $52. The highest maybe around 70 or what. I mean, at least a delta of about $10 to $15 would be there. If I'm able to buy the lowest price crude today, which is being sold in the open market, why not I do it and get it away? And here one side, a little bit of information I thought I'd give you about, because not that I'm from a business family, but I just give you an opportunity. I mean, how the dynamics takes place. We were in Kuwait way back in 90 when the with the KNPC, I was on secondment from Indian Oil. We were doing some work in Kuwait refinery. Unfortunately, on 2nd of August, there was a big bombardment took place from Iraq, and then in the process, all of us became overnight from Kuwait citizen to, Kuwait national, Kuwait thing to other affairs. Are you hearing me? Hello?
Yes, sir. Yes, sir. We are able to hear.
The story is like this, that then we were not knowing how to come out of Kuwait and come back to India, because we were all stranded. There was no flight, nothing other kind. And finally, what we decided that, okay, from Kuwait, some 20, 30 fellows of Indian Oil fellows and ex-Indian Oil fellows, we all moved to, what is the place? Iraq. That is Baghdad. From Baghdad, we are supposed to go to Amman. From Amman, we are supposed to fly back. Amman is in Jordan. The moment I went to Baghdad, and there were a lot of touts looking around saying that, hey, because Iraq was with that time more of a national country, no? There is no free market. So you will have all the free gadgets, whether it is camera or 2-in-1 or whatever you said, about is all available in Kuwait. So if anybody coming from Kuwait, always people are there to buy it. So I was not having money because my money was in bank. So my friend only said, okay, we will take you, there's no problem. Then you come back and give the money when the things come about. So I was on borrowed money, borrowed with others. When I'm looking around, the people are saying that if you have got any long play cassette recorder, no, or a video recorder, things like that, we can buy. So what I bought, it was for $100, dinar, Kuwaiti dinar in Kuwait. And then the Air India fellows who were buying the ticket, selling the ticket for us to travel from Amman to India, Mumbai, they said whether you give in KD or ID is one and the same. There is 1 KD equal to 1 Kuwaiti dinar equal to 1 Iraqi dinar. And that's how those days was the management. And the people outside, they're interested in buying some of your gadgets, whatever you want. And I talked to some friends, why not we sell one of our, whatever we bought in Kuwait, and we'll sell it and that money will come. where they'll give ID only. There is a Iraqi dinar they'll give you, but the inside whether you give KDR ID is one and the same for the government which is doing it abroad. So we'll sell it and do it abroad. And finally, we sold it for 900 dinars. That is, I bought for 80 or 90 KD, and whereas I sold it for 900, which is 10 times more than the price what I paid. And I substituted the money for all my friends who were traveling with me back to India. What I'm trying to say is that the opportunities are plenty. So we'll have to keep looking at what is looking around us and how I'm going to make a difference. That's what it says. And if I'm able to buy for India, you can say straight away $0.7 billion per annum is going to come. I think all our finance ministers should be very happy that at least some extra money is coming. See, what I'm trying to say, the ministry should be really pushing them, saying that, hey, why the hell, what is really going wrong with you guys? Why you're not able to process the way in which like Naira is able to do or HMEL is able to do. HMEL, Naira, all these stores are operating around 10, 12, 13, $14 per barrel. And everybody is very happy because they are also getting NRL. The Murthy Refinery is also getting around $14, $15. But the difference is that NRL is crossing indigenous crude, but crude cannot be sold anywhere. And there are some financial jugglery. It's not a real value. The real value is given by HMEL, IOC, Paradeep to some extent, and Reliance and this. So people have to make some kind of a comparison. So some of you know what you call either Pradhan or even or Madam, what's her name? I forgot her name, whatever her name is. You tell her, boss, it's time for us to start thinking as India as a ministry as a business house rather than just only for Southeast Asia. So that's what. And similarly, if I'm able to do the overhead corrosion, if I'm able to predict and do it about using some CFD, because we found that during our internal exercise, any capacity more than 10 million, there is a problem of maintaining the overhead system unless some new things are happening. So maybe we'll have to start looking at the injection nozzle, whether the right pressure is happening or is it rightly designed, or maybe I'll have to put injection in two places. All things have to come about. And that's again another 0.5 billion opportunity can come about. So in turn, what I'm trying to say is that there are many opportunities available within oil industry, and maybe a team of 3 or 4 or 10, whatever number you think the best, start looking at the problem. Maybe you can take the problem and we'll start going more and deeper and find out what it is we can think about. That's what it is all about. Okay. I think this is the last slide, if I remember correctly. And same is the case for CO2 and energy, etc. And what is the road ahead? Road ahead is that it's all available to you. This use the matrix which I gave you. We can start looking at, okay, these are 3 or 4 funds which is appealing to me. Then maybe I can work on this and try to see what way you can get the value out of it. That's what we're trying to say about this. Certainly, I mean, the biggest task I find is that the item number 5. Because unfortunately, of course, maybe it's because of me having generated some of the positive, negative vibes in some of the people around. Invariably, I've seen that whenever you do some work, there are at least 10,000 people will be against you, and whereas you have to have your tenacity or energy to succeed about it. And that one small simple thing is that which Gopi was mentioning, that one of the most satisfying moment as a chemical engineer, I can say it is that we had put up a benzene recovery plant from the FCC gasoline. FCC is one of the units in our refinery which produces gasoline, which is high octane gasoline for the going into the petrol. But while you are making it, you also make benzene. The benzene specification in the Indian market is less than 1% volume. In the benzene petrol which is being sold, it's not contained. Whereas in California, which is in the US, they say it's 0.62. That means they are further saying that. Now, question is how I'm going to take out this benzene from the gasoline. The one school of thought is that what Indian Oil and most other fellows have done is that they take the gasoline from FCC, they just send it to one hydrotreater. The hydrotreater, what happens is that olefins get saturated to respective paraffins, and benzene also gets saturated to what they call it as the cyclohexane. I think you are losing as the benzene value maybe around $900 or maybe $1,000 or $1,200 per ton. But the moment it becomes cyclohexane and it goes along with naphthalene, the price will be hardly about $300, $400. I mean, I'm doing energy and I also losing the value. So what is the way we can think about it? The question came to us, and of course, mind is a little crazy. Then I talked to IIP Dehradun, our friends, Dr. Garg and company. Garg, he told me that Murthy, you send some sample and then we will find out what is the way we can do it. He said, yes, what you're saying is this. If I take out the benzene molecule around, because nowadays people talk in terms of what is it called? No? That MOE, that is, what is it called? I think. Anyway, I'm not getting the exact term. It's that like a molecule, like a honeycomb structure, no? In which it allows only that the molecule of that particular size only can go. Macroorganic framework. MOEF, that is Metal Organic Framework. Something of the kind, why not we try and do it out? Because we had some time of about 2-3 years by the time the market is becoming of 1%, 0.62. Until that time, we can always manage it. Okay, we said we have got 3 years time, and why not we do it double? He said, we don't have to go to MOEF and all, we can just go with simple extraction. I told boss, extraction may not be good because it has got diolefins and because diolefins are very aggressive. Because the moment it sees some acidic means it starts polymerizing, it starts cooking up the entire thing. And I leave it to think about. And he said, okay, we'll do it. And then finally they tried once with sulfur as a solvent and they spoiled the entire pilot plant. They have to clean it within about 2 days of operation. Then they switched over to NMP. NMP is a N-methyl pyridine. Pyridine is another solvent which is used for lube oil, etc. He said this also can be used. Okay, they did, and then found out what is the success story to do about. Then the question came that can we rely on IIP data to do it? Then we did all our exercise saying that okay, 10 times you run your pilot plant and take the results, and then get that sample, raffinate and extract, and find out how much of money I'm losing, gaining, etc. And finally, for process engineering work, we took the help of technique. That is scaling up from the 2-liter hour plant to something like this unit is around 100 tons per hour capacity plant. So we need to do the scaling up. What I did in this a glass tube of about 2 inches, I need to put a extraction column of about 3.5 or 4.5 meters diameter. So what way we can do? All the things were done by the people, and now the plant is running for the last, I think 2017 or 16 they commissioned it. And then they got the presidential award also. And plant is running. It's the first of its kind in the whole world, and is running. Then we started looking at that. What is that which made a difference? And finally, we found some species which is there in our high severity FCC, which makes a difference. That is the one which is causing. That is in ppm level, which causes problem to rest of the fellows. Otherwise, other fellows also saying the yes, they can do. We talked to UOP. They said no, we don't want to do it. We don't want to touch. At the moment olefins are there, we will not enter into the territory. We talked to Exxon, they also said no. We talked to other fellows, and finally, all Shell also we talked to them. They also said no. But now UOP says that they mistake that they have otherwise they could have become a joint patent holder with us. Now joint venture we have done. But now Technique has got the advantage to do it. What I'm trying to say is that be bold enough. Let's not fear for the failure. And second thing is that yes, I mean once you own the problem, some new solution will come. But let's not forget the chemistry or thermodynamics or any engineering discipline which is needed about. That's all in nutshell I can think about. Okay, thank you. Thanks for your time. If you have any questions, maybe you can get going about. Yeah, one Mr. Muthu is trying to ask some question. Please go ahead, Mr. Muthu. You unmute first. I'm not able to hear you.
Good morning, sir. My name is Durai Manikam. I worked under Reliance Petroleum Limited. Yes, sir. My name is Durai Manikam Muthu.
Good morning.
I worked under Reliance Petroleum in simulation department up to 2004.
Oh, very good.
And nice to work under you and a nice lecture from you. It is very happy to see. Happy to hear your voice after a long time, almost 16 years.
You are in with this guy, Nilesh Modi and company, right?
Yeah, right now I am working in the Petrofac Engineering Construction in Dubai, UAE, good. And we are mainly dealing with the refinery and oil and gas.
Okay, nice.
And yeah, yes, sir. Recently we are working for the CFP, the Clean Fuel Project in KNPC. Almost commission is going on one of the refinery right now.
Okay.
So I have two questions. One question is, the carbon emission is one of the main source for the refinery, and what refinery has been done, what can be done to reduce the carbon emissions? Because even recently the carbon capture is one of the main technologies being talked about it. This is first question. Then the second question is, nowadays since we are going for electric vehicle, even the bio-based which work under for diesel from biodiesel and all is not going to workable, and people are talking about electric vehicle as well, hydrogen-based vehicle. And now, in order to sustain the refinery for a long time, now people are talking about C2C, crude to chemicals. So how in the lecture you said another 50 years still we can sustain with all the crude everything. Afterwards, what can be done? So basically, first the question is how instead of producing diesel, petrol, and all the things, how we can move to the C2C? What is the best technology? After that, after 50 years, how it is going to be? Can you please explain, sir?
Durai, you asked very tough question. probably people like, what's his name? Partha Mitra is the right guy who have answered this question. But to my knowledge, whatever I can think about is that certainly electrical vehicle is making inroad. There is no second opinion about, but I am a doubt how far the electrical vehicle is going to get going about. The reason is that the battery weight and the battery itself can create some hazardous thing, because the battery also with something like KV rating, it's not like 12 volt where things can run about. That is one thing. Let us not leave aside the negative aspects of it. People talk about that you go to one place to another one, like you're filling the petrol, you can change the battery and put a new battery and run about. That's what the people are talking about. That's one thing. But why, coming back to our own refinery area, that why I'm saying that yes, it is sustainable. See, refineries are the only fellows in the whole world. If you look at the last 30, 40 years, or at least in Indian context, they have what is called PCRA. The PCRA stands for Petroleum Conservation Group or something like that. They try to sell that they don't use the LPG like this, or don't use some petrol in this manner. Try to improve on the efficiency factor. In the initial days when the Ambassador car was coming, it was coming hardly about 10 or 12 liters, 12 kilometers, or even maybe less per liter it should be givable. But nowadays you've got the modern cars which are of hybrid nature. It can even give around 20 to 25 thing can go there. Some fundamental research can be done on the IC engine. What is it which is holding this Carnot cycle that I'm not able to get anything more than, let's say, 40 or 45%. I don't know what number it is today. But certainly you can't go like a a refinery where the efficiency of the heater, fired heater, or even gas turbine because of back pressure, HRSGs, that is heat recovery system, etc. You're able to go as high as about 90, 92, depending on the dew point. Similar way, at least can I go to at least some 70, 80%? What is that? That means my flue gas, which is leaving the combustion chamber, at least should not go anything more than 300 degrees. If I'm burning it at 700, 800, if I'm letting it out at something like 600, that means I'm straight away losing that money. What is that we need to do? Maybe enriched oxygen. Maybe there's one solution we can think. I don't know if it makes any sense to look through about having an oxygen cylinder or something like that along with the car and doing it about. Another one is that fuel automation. Is there anything which is happening? Because the particulates are coming, means that means some of the unburned hydrocarbons are coming from particulate diesel. You must have seen, because we did some work with Myco as well as that, SAM. It's in Pune. If we start looking at what is that which is making a difference, why Toyota is not able to run in some whereas Mahindra is able to, or vice versa kind of. All that it talks about repeatedly is that look at the fuel, which particular species in the fuel which doesn't burn that easily, which contributes to the particulate matter. If you can start working on this area, probably you'll find some solution. It may be that 1 or 2% of the diesel which is causing this problem, whereas the remaining may be running very well. Like you remember, they put the Ceton improver, that is at some 2x, some nitrate or something like that, nitrite or something which is being added. Maybe we'll have to start looking at additive route to improve the efficiency, or the engine design to improve the efficiency, or take out the species which can make a difference to you. Or use the heat, whichever recover heat. Maybe you remember that nowadays that they have got this thing, I forgot the name, bimetallic or something, by which you can create some electricity, and which can even use it for your air conditioning purposes instead of taking from the main engine. Hello? What I'm saying is that unless you try to go back to the board and find out is there any way to do it about. Even I've seen in some place they do I've seen origami, ori emulsion, something like technique, wherein some amount of water is added to make it pulverized so that it works about. So these are some of the areas where people can think about it. Coming back to the bigger size in the refinery, which I have been now trying to work with some of the people here about, is that you remember the hydrogen plant. Hydrogen plant produces a lot of CO2. And it is particularly available in the very pure form. And then once I have it, because hydrogen plant is not supposed to have any sulfur, etc. So that way CO2 is available. At least can we take the CO2 and use it for something which people are talking about? CO2 with water can make ethanol, or CO2 with water can become methanol and things like that. If that is the one cycle they are able to create, we have done a greater thing. But above all, main thing which I am asking this our catalyst fellows is that I used to tell my friends in the R&D, boss, I have given you the VGO molecules, you are supposed to make propylene. Why are you making methane? Similarly, hydrotreaters. Any hydrotreater you take, whether it is a naphtha or diesel or kerosene or VGO, all the hydrotreaters, I produce some C1. From where this C1 is coming? Because unwanted hydrocracking is taking place, and that again getting converted to methane after hydrogenation becomes methane. can I start looking at the catalyst by which I can reduce the C1? The moment I reduce C1, your hydrogen consumption comes down. You know very well, being a good chemical engineer, there is something called chemical consumption. There is something called solubility, which is the total consumption come about. The chemical consumption, they also put in account of C1. Can I make, because if you go purely from sulfur, nitrogen, and some of the olefinic saturation I'm supposed to do, you're not supposed to consume anything more than maybe around 0.2 or 0.3%, or maybe 0.4%. I don't know whatever number is going to come. Look at what I'm consuming as a chemical consumption. What is it which is happening? Why I'm doing this? That's why the isothermal technology came from DuPont, but unfortunately, it's not taking the shape it is supposed to take this. So we need to start looking at again back to the fundamentals and see it again. If somebody is willing to do, I don't mind even sponsoring some work with Indian Institute of Petroleum, because you do have some tie-up with them. You can request them, boss. I mean, we're all small company. Take it maybe what only that your salary part and when you have to do. Anything you are doing for experiments, we don't mind sharing with you to do it about. Because there are good people in Indian Institute of Petroleum willing to do the work, but somebody has to give the thought process to them to work through it. Or maybe I can even influence Dr. Garg. But the moment we work with Reliance, there is every chance Reliance may take your idea and then they may put up a patent, fair enough. But if you want for your company or your everything to do, let us believe in our people who can make a difference. That's what I want to say about it. I'll put it this way that today, if my CO2 emission in the refinery is X, at least in my view, if all of us have put our brains, maybe within about 3 to 4 years or maybe 5 years time, we can at least bring it down by about 70%. Sorry, by 30%. That means by today, if it's X means I can bring it down to 0.7X. I don't know, I mean, how much is in your refinery you're using that roof preheat? Because I've seen in Chevron, it's hardly 1 degree drop every 5 years, because they have done the extended design in such a manner they don't have any drop of preheat. Whereas in many refineries, when the preheat starts with 270 or 280 degrees, but by the time end of the year, it comes down to 240, 260. That means 30, 40, they're losing. That means so much of fuel firing I'm doing. See, you have to start looking at the efficiency at its best all the time. Flaring, why I'm doing the flaring, whose money I'm spending it over. Start looking at that thing. Okay.
Yes, sir. Yeah. Thanks a lot for your response, sir. But even nowadays, even the Elon Musk also announced that first carbon capture technology he has announced for $100 million. So we can work on this for know how to capture all the carbon, everything for the best technology. Then we may be one of the competitor for that.
Yes, I agree with you. See, one thing is if you go into the flue gas area like FCC or like any other furnaces, you have SO2, you have got nitrous oxide, so on. But in your hydrogen plant, there is no such. No. See, the best way to use is that hydrogen plant, and then of course for hydrogen purpose, people are saying that you go for wind or solar to take it about. At least India has got all the coastal belt, no? So any wind and solar combination can give a best thing to think through. See, we should not be thinking that only Westerners can do, Indians also can do. That's how I believe it about. Well, see, India has got Taj Mahal. There's no Taj Mahal around the world anywhere. Why India only had the Taj Mahal? Or you go to that Ellora case. People have done wonderful. Only thing they have taken a lot of time to make it about. So, see, first of all, I should believe that yes, my people or my engineers can do a great work. And I have got greatest regards for the people from Annama Institute. I mean, not that I'm trying to flatter you guys. Invariably, I've seen that fundamental knowledge, what the people, maybe your teachers are excellent. That's why you guys have got picked up very nicely, I should say it about. It doesn't happen with the same from other colleges. See, IITs may have some names, not that I'm against them, but when you ask them some fundamental questions, even PV code NRT, that equation itself, people find it very difficult to answer it. So, first thing is a self-belief, yes, I can do it, or I want to get it done. See, even after working for 4 years, let us say if you fail, at least you have done your efforts in the right manner, no? Rather than wasting your time in unwanted things. I look at that way. And Dore, I learned a lot of simulation from you. Yesterday, somebody was asking whether you guys can do simulations. Hey, all of you, Dore Manikim is an excellent simulation master. Catch him wherever he is.
Yes, sir. Thanks a lot, sir. Everything I learned from you only, sir. Without you, I cannot enter to CTS department, sir. Still I'm remembering you, sir. Thanks.
Don't give unwanted things to me. I did what. See, simulation is there in the head first. I always tell my youngsters that way. But if the head is saying something is not yet, the computers are somebody else said, no. But anyhow, it makes your life easier. There is no doubt about it. You guys have done wonderful. You only taught me what is SRK, what is that? I don't know what are the equations are there, thermodynamic equations. No? I don't, anyhow, in front of Gopi, I don't want to say he's another master sitting in front of us.
Thanks a lot, sir. Thanks, sir.
Okay. There was a couple of other people also wanted to ask some question. I don't know.
Good afternoon, Murthy sir. This is
Yeah.
Aarti from BPCL Kochi Refinery.
Yeah.
Sir, I'm a chemical engineer who graduated from NIT Surathkal in the year of 2018.
Good afternoon, ma'am.
Sir, I have a question. It's been only 3 years for me in the refinery. So since the day I've joined, now I'm in project technical department. So a few questions. I come across so many articles where different refiners and the Indian refiners choose different projects. We have gone for petrochemicals and in BPCL, and IOCL is going for and HPCL is going for expansion in all refineries. So there are different kind of diversification happening in the oil sector. So I just don't understand how we choose such diversification to be profitable, or it's value adding, or on what basis we choose, and how we go for such different projects. Sir, I just have a question like that.
Yeah, Aarti, I mean, I'll put it this way that since you are from Cochin Refinery, and I had been to Cochin Refinery a couple of times, and last year also they came for some training and all. That's a good thing. I'm of the opinion that, see, you have two FCC, which one is from UP and another one is, I think, from Stone and whatever thing. And you do make plenty of C5s. C5 stream, which is there the gasoline purpose. So if you start looking at the C5 stream and converting them into isoprene, this is one technology I don't know who is having, nothing is known to me. The isoprene is a very good thing for you making the natural rubber. And Kerala being full of natural rubber requirement, and then many times all kind of prices go up and down, etc. So if I can take out this C5 from FCC, just a pure distillation only, what you put on deep international, you get the column. And then can I convert this into isoprene? What I need to do? See, the problem is that if I buy technology, it comes with enormous money and it comes with a lot of fat and so much. Because not that I'm against any of this technology being bought about, but invariably I find that these technologies were developed way back in maybe 50s or 60s or 70s, and the guys have never got any improvement. See, one of the biggest drawback I find is that unlike Shell, most of the technology providers, they don't have any tie-up with the refineries on a day-to-day basis. See, a refinery can understand because of different crudes being processed or different feedstock or different catalysts they try about, and what way that information has come back to the designer to improve that design area. With all due regards, I'll just give a simple example. Coker. In the coker, they have got a gas con section, which is for removal of C3, C4 from the gas before it goes into the fuel gas pool. We have got primary absorber, we have got a secondary absorber. All of us as a good chemical engineers know that for absorption, there is a heat of absorption is there, and then the temperature goes in. So you need to cool it, because absorption thermal cycling is, unless the temperature is around 40, 45 or even less, your absorption efficiency will fall down. So we have intercoolers in the primary absorber. You won't believe in refinery Jamnagar, we fought with this Forster fellow saying that, boss, why did you not have it? Because we have the intercooler for FCC gas con. We have a similar intercooler in the even in our crude unit. We have got a gas con because we want to recover the C3, C4 from the your hydrotreaters, which is again not a good design. Design means from a hydrogen perspective, but once it's made, at least you are recovering. You are not putting it in the fuel gas pool. The LPG is always better price than the fuel gas, which is going to flare, etc. No? And when we asked Forster, they said no need. Then we showed them by simulation. There was one guy by name Nilesh and all the fellows were there with Remanicum was to go. We told them, boss, this is what the money you are losing it about. Why the hell you are not using it about? We fought with them and got the two intercooler installed. This happened way back in 98, 99. Now you come back to IOC Paradip, which is in 2000, I think 2005 or 6 or something. They must have commissioned the plant. And there the same primary absorber is with the Forster design without intercooler. Then what to tell them? What we told them in Jamnagar way back in 99, there has not been transferred even after 15 years. This is how the technology flows work. My request to you, Aarti, is that you have a very good R&D at BPC. I have seen Jaya madam and so many people. You ask them this problem: can we make isoprene from this C5? What is the thing to do? And similarly, your LCO, the light cycle oils come from FCC, which is particularly your high severity FCC, which is making maximum. Yeah. It will certainly will have 2,6-DMN. That is all. First of all, it will have plenty of naphthalenes. And again, another one is that can you do some alkylation with some methyl to make it 2,6-DMN? I was told it's around $10,000, $11,000 per ton. That is your LCO. If the naphthalenes are there, it's already spoiling your, what is it called, your signal number. So what is the point of doing that? That is, can I remove this and do it above? Think through, because it's one of the pet project of our doctor, Professor M.M. Sharma. If somebody wants to do, I don't mind sitting with you people and doing it abroad. It's really worth it. Let's not talk about the money, because money is one, what you call, for my subsistence, I need money, that's okay, that's a secondary. But I got enough money from Reliance or IOC, that's fair enough. And now I have come to the extent that if some of our thought process can trigger the minds of the people, young minds like all of you, if we can make something which is good for the country, no, it's a happiness, I can put it up there. See, I have just done only BTech. I'm not any either MTech nor any doctorate. But your mind is such that can I do something more than what my forefathers did? And that's how we could make 6 or 7 patents. I told you, one is the DSO, that is disulfide oil. We're now using this.
Yes, so we have a ATF Merox also, sir. We have a ATF Merox at FCC.
I know, but if you are using for naphtha cracker already has got some sulfur, you don't need. But if you have got a gas cracker, you need it. See,
Yes.
Reliance has got gas cracker in terms of putting on in Nagatone as well as in Dahej, they have got. We told GAIL, they told the GAIL Fluid Yoga at Pata gas cracker, why don't you buy it from? And the bumps, I'm sorry to say it about, they didn't want to use it at all. They said, no, we don't want, we want to buy DMD. Why this nonsense, you tell me? And finally, when we presented to CHT, I mean, my team has presented, and after that, minister started firing all the fellows. Nobody shall buy DMDs from outside. Why it has to come from political fellows? Why technical fellows cannot work together and make a difference? That's where the question comes. See, certainly, unfortunately, when we were in Indian Oil, we were a little against any of the R&D fellows because they talk purely and see the language. If we do not understand first thing is what automatically I'll start hating. Who are these fellows into coming and teach me something in Sanskrit or something in Latin which I don't understand about. But once you start knowing what is happening, what is the way we can make a difference, I think objectives should be made clear. Can I make new value from this FCC? You start this question, I think any help is needed. You know my number, you know my email, I'll certainly work for you guys. Don't worry about it. My promise is that. In fact, I've been asking IIT Dehradun lately, why don't you do something? But they say, yes, we can do, but nothing has come so far. Plus, there's another thing called EPDM. I don't know. EPDM stands for, what is it called? Ethylene propylene diene monomer. I think, yeah, EPDM. No? Yeah. Ethylene propylene diene monomer. It's also guarded technology by some few fellows. My classmate is there in that company which is working on this. And they are making money because EPDM is used in all the cars. The cars, whatever you say, anything which is related to plastic is all from EPDM, which is supposed to be weather resistant because cars are always seeing sun, rain, all kind of things is saying. It's doing it about. Why not India makes it and do it about? Nobody makes it in India. If EPDM, because ethylene is available, propylene is also available, what else you need, you tell me? Having got FCC in the refinery and that is where you are working about, if you have an aptitude for this and if you think that yes, let's not fear for the failure because there are thousands of things in life we do it and we fail. What is the harm in that? That mindset has to first get away. That is more important to us. And all of us too, and I'm sure with Gopi and all of us will try to support you. We'll make it happen.
Thank you so much, sir. Thank you so much for the answer. And it was very interactive and it's a great opportunity to interact with all of you. So thank you.
Great. Yes, Anirban. Mahindran.
Yes, Murthy sir. Good afternoon.
Yes,
Hello.
go on.
Yeah, I am also from BPCL Kochi. I am working since 93 onwards. I am the in charge of the petrochemical. So recently we have commissioned 3 units in Kochi. In one unit, we are facing some issue in reactors. It's a reactor supplied by MAN from Germany.
Okay.
Is not coming from India due to COVID-19. So during normal operation, there is a mismatch in the levels inside the reactor. So last week, you taken a shutdown for checking internals. So there is no man way. For entering, you have to remove the pump. The height of the reactor is 9 meters. With the help of the drones, is it possible to check internals?
No, normally what we have done is that we have used the help of BARC fellows. So what happened was one of our Bijo hydrotreater unit, there was some failure, a premature failure of the catalyst, and of course, it's a mistake by us only. That means whatever way the people are supposed to do the pre-sulfating operation, because normally catalyst is bought at outside state. After you pre-sulfate before the system is, and that time we have to drive away all this moisture which is inside the catalyst pores. And there was some screw up, and finally we took the help of this VRC fellows because they have got a gamma ray or something like that to do it. What is exactly happening inside? But now, if you put a drone, you will again get the permission because any gamma ray means it's all because of radioactiveness. No, when you need to get all the permissions as well. So if you talk to somebody in the VRC, probably they'll be able to guide you. That's one thing. Another one is I don't know. I mean, whether that there is one company called Plastic Resins and Chemicals in Darangadara. That's in near Tutukurin only, and of course I don't know, or even Hazira fellows, not Hazira, the Heights fellows may be doing because of making PVC. No, there is a polyvinyl chloride. So we do a stir reactor only, which is again reactor mounted with the pump, whatever the motor, whatever you're saying it about. And there again we had some deep pneumonic gates to find out what is really happening about. I don't know, something other kind we can think through about.
Murthy, the issue with is not on the catalyst side. It's on the cell side. Cell side, we are circulating a salt.
Yeah, that's right. ESL is jacketed one for cooling because I've seen the PVC vessel is also like what you're saying, 9 meters, I don't know, 3-4 meters. I mean, I'm talking about way back in when I went for training in that unit, but I don't know where the plant is running or not. But most of the PVC, that is the polyvinyl chloride units, I got a similar setup. And the shell side is first chill water, then hot water, all kind of thing. They do it for keeping the temperature on. Then polymerization is the exothermic. Now to control the temperature, what they do is they make the changes in the temperature with the water only. They do it. It's a glass line, if you remember correctly, that shell. I mean the reactor. Anyway, you need to talk to some of the instrument guys who are there in the system to think about what is the way they can overcome it. Otherwise, I don't know. I mean, what else I can think about.
The same arrangement is there in Chemplast PVC plant in Kadalur also, sir.
Possible, right? Yeah, most of the PVC
that's
plants
also,
have got similar.
That's also something similar to this, around 8 or 9 meters tall 8 or 9 meters tall reactor with a pump at the bottom for entry.
Yeah, it's a slurry phase reaction. That's why they have to put it.
It's a slurry service.
Yeah. Thank you, Murthy, sir.
Yeah, but you are suspecting problem with the water side or problem with the
no. Side? We are suspecting salt formation in the cell side.
Salt formation.
Yeah, salt formation.
Salt.
Yeah, salt.
No, invariably, see, another one, what people can look at it is that, I don't know, I mean, see, salting means excessive temperature salt can form. See, like I'm trying to take one, some relation, I don't know how far it's right, but nevertheless. See, in the crude oil, I told you that we have got some salt. I told you it's around 10.
This reactor shell side is having salt actually. So
no, that's
not
right.
with water.
You're right. What I'm trying to say is that in the crude, when we add, when the crude comes along with the water, 0.3% or 0.2% water, and that carries a salt of something like concentration of the salt in that water will be something like 15,000, 20,000 ppm. See, what is being talked is that the moment salt is getting to the salting zone, then you end up in this kind of issues. I think you have to start looking at one is the surface, because surface is hot. And second thing is that what is the amount of water circulating so that it can share off the salt even if it gets formed. That's way to look at it. So that's why we add some 2% water continuously on the crude to forcibly clean water we add on there. Maybe you'll start looking at your salting temperature and shear stress on the surface. So two things you can look at. What is the crystallization temperature of the salt? If it forms above some 40,000 ppm, there is one number to think about. But by the way, what salt is there? Sodium chloride? I don't know. What is that?
No, sir, this reactor system is having salt for heat recovery. This is KNO3 and NNO3. It is not water, it is salt only.
There's no solution. That's what you're saying?
No, solution only. We are maintaining around 320 degrees centigrade.
Yeah, 320, anything will get salt will always form. No? Water will evaporate, no?
No, salt will form. The salt will form at solid at 140 degree.
Yes.
Actually, sir, it is solid salt which is melting at 140 degree, and that we are circulating in the reactor shell. It is not any solution with the water or something.
Oh, okay. It's like molten salt.
Yeah. The salt will start melting at 180 degree.
Yeah, molten salt. Why don't we talk to some of the fellows that solar fellows are there? No? They use the molten salt. You ask them how they maintain the salt. I don't know. That means salt is solidifying. That's what you're saying, not this thing. When the temperature falls, the salt will solidify. No. So we should minimize the area where the solidification is taking place.
Ankur?
Yes, sir.
So if that is the case, you have to always maintain the temperature more than whatever 200, 250, whatever temperature. Because see, some moment, see, don't look at the bulk temperature. Always you have to look at the what do you call it? What do you call it? Tube metal temperature, what we call it as a. With any chance by which the tube metal temperature can fall below certain number. Simple that. It's always the bulk temperature is misleading if you ask me about. Like even in any cooling tower system, no, we always say that my outer temperature is 42, 45 degrees. Why the scaling is taking place in the heat exchangers. But the moment you go into that, you'll find that the inlet tube metal temperature can be even 60, 70, etc. Then actually salt will form.
Murthy sir,
There is salting is taking place because of evaporation, but here what you're saying, salt is getting formed because of low temperature. So what is the low temperature zone which is there in the system?
Murthy, there are 3 compartments inside the reactor. There are 3 compartments inside the reactor. There are 2 plaffer valve in between 2 compartments. We have doubt in the plaffer is working or not. That is why I'm asking you that can we use the drone to check the salt path and flapper valve position?
Yeah, see, another one is that normally what we do is that, see, this may not be the only technology available from the company what you are saying about. If any parallel peer to whom they are, and if you're able to talk to them, then they'll be also giving some solution. Other one is that EPTQ. EPTQ is one of the, what do you call it? I mean, that magazine, no? In which you try to pose this question, there are thousands of people willing to share their idea to you. Maybe you can look at, you can talk to them also.
Okay.
To be very honest, I have not worked in the plant, so I mean, neither I know much about it. But certainly, I mean, EPTQ is one area where you can send your questions, and there are many people will be able to answer you.
As you said correctly, yeah. As you said correctly, I think gamma rays with the bark is the better option, sir.
Which one?
So gamma rays is the bark which you said initially. That is a better option to check the baffles.
Yeah, fine. Yeah, that's the one way of doing it. But one thing is you need to be extra cautious with all the safety precautions you need to take. Because the guys, when they're doing it done, nobody is allowed to go within about 2 meters or 3 meters area. So quite a radiation is pretty high, no? Okay.
Yes, sir. Yes, sir.
Thank you, sir. Thank you.
You're welcome.
Muruganandam has raised his hand.
So one more person raised the hand. I don't remember who was that.
Muruganandam.
Yeah, sir. Sir, good morning to all, sir. Very nice presentation, sir. Actually, I joined our session in the middle of the session, sir. I was from Gale Pata, sir. In Gale Pata, we are using DMDS for the ethylene cracker, sir.
Yes.
Just now you said, is there any better option, sir? Because I'm basically, I worked as a deputy manager fire and safety in Gale Pata. Because, you know, DMDS, I'm having challenges for manual handling and the gases, you know, sir. That's why, is there any other option, sir, for cracker?
See, from a safety perspective or from a smell perspective, both DMDS and the DSO, the disulfide oil, both are same. And now what we are doing a drum filling at Jamnagar. So if you can talk to Jamnagar fellows, or if you tell them, or your Gale who is interested, I can link up with them and then you can take the call from there on. Because certainly it's a Indian technology. There is one way of looking. There is a wealth from waste. That's how we put the thought process together and made it up. It must be getting sold for, I mean, the actual value may be around not more than $100 or $120. And if you're DMDS, you're buying it, I don't know, whatever price, $3,000 or $4,000, the wastage of money. Any refinery nearby can supply, but only thing is that the patent rights, somebody has to say it. Because what happened, because the smell, we put one, some perfume also into that. So that the people who are operating, they don't get any thing bad about it. But certainly we wanted to be very specific about the sodium content, because even for the cracker plant, the sodium content in any of the product which is feed which is going should not be more than 0.5 ppm. So that we have ensured through a adsorbent bed, which we develop on our own.
Thank you, sir. I will touch with you, sir. Thank you.
I was cursing Gale. I'm sorry that I cursed you also then. I used to talk to one person. I don't remember the name of the person. I used to tell him, boss, why don't you take this product from us? It's available much more cheaper. And as usual, bureaucracy system, they never wanted to do anything about it. And that too, Reliance means always people have got some problem at that time. So I told him, we're also Indian. Why you take that way? Anyway, it's okay, part of life.
Thank you, sir. Thank you.
So any other questions from anyone? Kindly please unmute and go ahead.
Yes,
sir.
go ahead.
Yeah, thank you, sir. Still remembering Murthy, sir. When I joined in IOC Mathura, he used to talk about only value addition all the time. And we used to work together, after office hours, almost after 5. And we stayed till together, up to 8, 9, like that, and we do a lot of things. And still, it never, unforgettable thing that the value addition which he made at that time was the solvent naphtha, which was used for the paint industries and the solvent industries, which we were able to produce with the least investment in the payback of less than a month. That was one of the best thing. And he always used to teach us and always push us to work on simulation. That was really helped us to have a good future for us. Thank you, Murthy sir, for giving me that opportunity. When it comes to today's scenario, which Duramanikam was asking about the carbon capture system. So in Kuwait, now there is a concept of blue hydrogen concept and how to recover the carbon capture and utilizing them. So there is exploring with our oil companies, mainly for the exploration, that we'll try to capture from hydrogen production units and utilize them for the exploring wells. They'll pressurize this carbon capture and push into the wells. That is one of the studies which is going on as a part of enhanced oil recovery project. So that may be the one of the aspect which may be in the future development. That's what just I wanted to share this side.
I am aware of two things. So one is that since I told you about hydrogen plant, which is the purest form, except it will have some carbon monoxide as well as it has some methane. And some amount of leftover hydrogen can be there in because they are using the PSA system. No? But some other people use the Vetrocoke. There is a KOH solution. They use it for recovery of CO2. So that may be still simple way to. One thing what they need is that put a compressor to the exhaust and then pass through that Vetrocoke solution. CO2 gets absorbed. Then your remaining can go back to wherever the location you can think through. And the second option, probably what I can think is that I was told that, of course, there is not as a CO2, but they are captured in the form of sodium bicarbonate. One of my classmates is with Manali Petrochem product. This is Shell with the, I think, what is that, the company? SPIC. There they have done some kind of CO2 sequestration, but converted CO2 in the flue gas directly into the sodium bicarbonate. So that is one thing, but since your requirement is CO2, the best thing is that either on the gas turbine exhaust, if that is a clean fuel, another one is that this hydrogen plant, which is again a clean CO2. And yeah, certainly, so we need to have some kind of breakthrough to get, because Reliance was trying a lot of efforts on the algae to oil. Because some of the algae they were trying to do that, the culture of the algae to find out which algae can work better in the salt water and some other things. But unfortunately, so far they could not try. In fact, when the crude price was hardly about $34, Mukesh Ambani, even in one of the meetings, he said, I don't mind paying a lot of money, even if I'm able to produce 1 barrel of crude oil at the cost of about $100 per barrel. Even then it's worth it. That's what he was challenging them. But to my knowledge, no breakthrough has taken place. See, anything to do with the bio-related things, it has got its own, pace of time. See, like any human being, that's also one more bacteria, whatever you call it as algae. Some days it may be doing wonderful work, some days it doesn't do any work at all. So it's you lose your credibility in terms of the yield, what you're talking about. Same case took place with the biodiesel, because we all thought biodiesel from Jatropha is one of the godsend opportunity. India can make wonderful and we can make. And finally, when we started going deeper, we find there is something called germplasm. It says that it needs the right seed. The seed should have minimum oil content of some 30 or 40, I don't know, whatever number it is, and your extraction ability to do it above. It finally happened to be not a so great breakthrough so far. Unless, and also needs a lot of water, clean water, not that saline water can do it about the Jatropha tree about. So all bio-related things, it has its own merits and demerits. So our way to look at for next 50 years or whatever thing, go back to chemistry and see that can I make all this oil to chemical or whatever thing in a smart manner. That is where that requirements I see it about. Or whatever CO2 I'm producing because I need some hydrogen. Can I minimize hydrogen use? Because hydrogen use theoretical calculation to do. No? I need to remove sulfur. The sulfur in the crude is, let us say, even if it's 1%, the sulfur is what molecular weight is 32 and hydrogen is 2. So 1 by 16 times. Even if I have 1 or 2%, 4%, I need 1/16 of that as a hydrogen. And same is the case with nitrogen, 14 and 2, 1/7 of it. Like that, if you start looking at what for I'm making this C1, C2, C3 for what purpose I'm making. C3 is good, okay, it is at least uses LPG or uses what is it called? No, your that propylene, etc. But C1 and C2, what I'm doing with the refinery, unless C2 go for ethylene production. So you ask the fundamental question to the the reactor guys. Catch the reactor follows, catch the catalyst follows, what is this happening, why I'm doing this. Or can I do like evaluated bed? No, nowadays the evaluated technology is available for removal of catalyst on a continuous basis. That means I don't lose activity of the catalyst. So what is the way I need to get it above? Maybe some bimetallic or trimetallic, I don't know what nonsense can have above. In fact, you won't believe, I used to ask one crazy question to our FCC fellows. FCC fellows, I tell them, boss, I'm not giving any benzene in the feed. My feed to the FCC is starting from C25 or C30, it goes up to maybe 60, 70, whatever number it is. When there is no benzene in the feed, why are they giving benzene? Why am I making the benzene? Then the question came, what is the way benzene gets made? It's not benzene gets made by dealkylation of the benzene ring in the monoaromatics. It's getting made because of dienes getting saturated to cyclization takes place and it becomes benzene. So can I prevent this happening? Or what is the additive I do it? Another one we asked them that I don't mind giving some additive so that any methyl group which is available with benzene you make toluene to me or make some paraxylene to me. Why the hell you guys are not thinking in that time? See, unfortunately, what is happening is that all of us are still thinking that any catalyst means only half the Topsa can do or anything from I don't know who other guys and Grace can do about. But if you start thinking yourself, you never know. Even some ordinary sand which is available in Kanyakumari, someplace maybe acting as a good catalyst for us. No? Everything is it has got some activity surface and pore volume. Can you do something out of it? What way to take a call? Take a call.
Durai Manikam.
Yes, sir. Yeah, this is once again Durai Manikam. Mr. Kobi has been very good introduction to about Murthy. Since I worked under him, I want to add 1 or 2 points here. Mr. Murthy is very sincere and hard working. He used to come to office at 8:30, 9 o'clock, and he work up to 11 o'clock. Then he will drive to office or 25 to 30 kilometers to home, then take lunch, again come at 8:30. He used to do every day up to 11 o'clock working. Very difficult to know to work. I don't know how he is working up to 11 o'clock. He is so much enthusiastic. And also he is he was heading the Six Sigma in refinery, and he was having black belt champion as well. And he has implemented so many mini projects where the refinery has made so much profit margin. And one of the project I privileged to work under him was the LCO maximization into diesel. Still I am putting in my CV because every year we are making around $10 million because of the LCO. And apart from Reliance, whatever his invention has done about LCO maximization, no other refinery has been done. There are so many things. But I can keep on telling on that because most of the time we used to travel to abroad for all the conferences and making papers, everything. And he has done a lot of work on the biodiesel and he has made the paper as well. And he's very knowledgeable and very happy to hear his lecture after 16 years and his face as well. Thank you very much, sir. Thank you for the Kobe and the team to make this.
Right. I get inspiration from all youngsters. I put it that way. I may be a good observer or good translator of some of the technical things or what we observe in the field and try to tell the people about nothing else. Anyhow, everyone can do. I mean, there's nothing big that only some X can do or Y can do. No, the question is that you want to. I'll put this in. I mean, see, there are many chemical engineers are born, many instrument engineers. A few people have spoken nicely. Whatever we said about what is the way we can do it about together. We should have an open mind because thanks to people like Surya Rao who have been teaching us, unless you keep your ears and eyes open, it's very difficult for you to know what is happening around you. A good observation. Because even yesterday, somebody was asking questions about the advanced process control. Advanced process control is nothing but the best operator. I mean, that's a simple language what we use to other people. Let's not think it's something Latin or Greek which I do not know about. But certainly, can a best operator remain as the best operator 24/7? Answer is no, because everybody has got their own what do you call it? I mean, the push and pull for some distraction keep taking place. Anyhow, I mean, I was lucky because my wife and children never troubled me for all this thing, because this is the only thing probably I know. That's how I done it. Nothing else. Thank you.
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir.
I invite Mr. Srikumar to share his views.
Yeah. Sir, it was a nice presentation, Murthy sir. It was an excellent one, and I really enjoyed it because I could remember what I am missing in petroleum, oil and gas industries. And you have touched upon many things, and this asset integrity which you have covered up is a new thing which I learned. And this you talked about the Kuwaiti return. I used to compare it with your Dhirubhai Ambani's Yemen silver coin episode, where he could make out money out of that. It was a nice presentation, sir. Thank you very much.
No, you are right. I mean, see, I'll put see, opportunities do come. Only thing is, if you keep your ears and eyes open, you can make money. I'm not saying that we made some vulgar profit, nothing other. See, people are, what happened normally, the people that bought in that country, they would have paid 1,400 dinars. Whereas I got it for 900, means they got some money they saved. But one thing, I deceived the Iraqi government because they said ID and KD of both are same. So in the process, we made money out of it. No, it's see, it's like this now. I mean,
yeah, you encourage opportunities wherever it's possible.
I was there for about 6 months as the government of India. That is from IOC secondary we went for supporting their operations. So because see, you need money for building a house, because when you're in PSC you don't get more than a few thousand rupees. So how to make the most. So on the base only I fought with my Mathura Refinery management saying that no, I want to make some money. At least let me go and have a look. See, another one of the good things I thought I'll just share about is not that money alone. See, the moment you see 3 or 4 refineries or 3 or 4 industries of this kind, because every refinery has got some great people and then great solutions they can provide. Unfortunately, they're all unsung heroes. Thanks to Sri Kumar, you triggered me to one more. I was in one of the committees when the Reliance started. We were we were transporting, what is it called, LPG from Reliance to all the way to Loni. Loni is near what is the place? Delhi. Yeah. And almost 1,400 kilometers, the LPG pipeline is the exclusive pipeline for LPG. You can imagine that was the first pipeline in the whole of India. When it first started way back in 99 or 2000, 99 you can think about. It so happened that some corrosion started coming in at different pumping stations. The people started firing, saying that the Reliance is useless fuels and they buy all kind of a crude and you never know what kind of LPG is coming. I said, and fortunately for me is that my boss said, Murthy, you have to go and handle this fellows because they talk all nonsense. There was one fellow by name Sengupta was there. I don't know, some of you may be knowing. He was a marketing head of the lab in what is that place in IOC. So a committee was made of GAIL. Ministry insisted saying that you guys are giving the product to them and you guys must be creating the problem to them. They were firing on Reliance like anything. I was supposed to defend Reliance. So naturally, corrosion, that time only everything was new because see, we all worked, but we all know, but suddenly not going. So when I went and told them, boss, I mean, I make LPG like the way you guys are making LPG. What is the problem? LPG I am making as per the BA specification. Answer is yes or no. You take the product by truck, you take the product by wagons, you take the product by pipeline, you can also take the product by cryogenic, because we used to send by the cryogenic system to Mangalore refining, Mangalore port, etc. There is no such problem as missing. Why the hell you guys are blaming? You guys must be doing something inside. Don't tell me all this story. No, I'm not interested in buying. You tell me, you take any GC or mass spec, whatever you want to do, you take my product and test 200 times. I got no problem. But don't tell me that this is all because of me. And finally, you won't believe it, because 5 years is like what I mean, the refined Reliance is just to come up. We were all like a baby of 1 month or 1 year old kind of. And other side, there are 5 fellows like HPCL, BPCL, and even though Indian Oil, my friends only, but they were also shouting at top of their voice. And you won't believe, then we said, okay, we'll go and look at the site where the problems have been reported. I think somewhere in Rajasthan, we found that the place where the things were happening. And you won't believe, when I was discussing, I was also breaking my head that where the things have gone wrong. I mean, what is it I'm doing? Whether LPG as per ISO specification, nothing but butane and propane. So they have some butylene or see, all the things are there. Some C5 should not be more than this. What is it? And my sulfur is hardly about 20 ppm. And those days also we used to make some 20 ppm sulfur as a spec of 1500. And you won't believe, because of cryogenic system, we pass through some dryer. Dryer means that means you take out my dew point of that LPG is minus 40 degrees. with all the thing, and still if somebody says that they are having some problem, then I could not digest. But luckily for me, you won't believe, when we went through the gale, one fellow in the gale, he pulled me, I mean, group of 4 or 5 going, and he just dragged me. He said, Murthy, just come for a minute, I want to tell you something. I said, at least, so who is this noble person who wanted to tell something? Whether he's going to beat me, I was a little worried about, but he took me a little behind. I went maybe around 10, 15 steps away from him. I said, Murthy sir, the main problem is that not with you guys. Our fellows, I told them not to put one corrosion emitter, which is causing this problem. It's a water-based corrosion emitter, which doesn't do any work in this. And they are putting it and creating all the mess. I asked them to stop it, and every problem will be solved. Then only we came to know that there is something called corrosion emitter, which is again, of course, thanks to GE, I could know more about the corrosion emitter. There is something called water-soluble corrosion emitter, something called oil-soluble. So we should use oil-soluble corrosion emitter if at all to go about. Some stupid fellow has put, okay, what is there? I mean, LPG, he must have done. In the process, we end up in all the mess. And the moment they stopped, after now refinery running, GAIL is running for the last 40 years. You can imagine. Otherwise, they were losing almost about kgs of rust they can get it up. So these are all some of the interesting, episodes you find as you move across. But more you try to interact with the people, let's not have the fear that, if I'm asking some question, I may be getting exposed. Because 1 or 2 times you get exposed for the stupid question or maybe coming about. But 3rd time or 4th time onwards, you'll be the victor, no? That is where we want the youngsters to think through. Anyway, I'm sure you guys can do wonderful things. There's no doubt about it. I got believe in all chemical engineers, all engineers for that matter. Forget about all other disciplines. I really don't enjoy working most with the CA. Once in a while, of course, some inputs that come from them. But by and large, I find engineers can make a difference in this country as a whole. I'll put it that way.
Great.
Thank you, sir.
Samarendra Das has some question.
Yes, sir. Good afternoon, sir. This is Samarendra Das from Chennai Petroleum, sir.
Oh, good afternoon.
Sir, thank you, sir. Thank you for sharing your knowledge on different aspects. It was a really nice discussion, sir. And sir, I am having just one clarification, sir. On your experience on this duplex stainless steel REAC react failure in any hydrocracker unit, sir. Actually, presently we are having our hydrocracker unit is licensor is Chevron. Yeah. So based on Chevron, this recently some 2-3 years back also they had issued some guidelines regarding this failure, and they're recommending to either upgrade or degrade to alloy 825 or carbon steel based on the parameter. So on this aspect, what is your experience, sir, regarding the failure, and what is the mitigation methods planned or done in any other refineries?
No, this where the problem was about.
Sir, actually, in one of the slide, that gap analysis slide, some 12 issues you pointed out. Now, there is one issue you had put like duplex stainless steel REAC failure in.
Yes.
Yeah, so with respect to
No,
that.
this I was told in Jamnagar. This happened. See, we had moved from carbon steel because see what happens is that the moment you use carbon steel, I think to my knowledge, your ammonium bisulfide, that solution concentration should not be more than some 2% or something like that. Then they went to Incalloy or Inconal or something like that, and finally they decided to go for deflux resistant. So what I'm trying to say is that in this also, you'll have to start looking at the micro area where the things can go wrong or thing. I'll put it, but of course, I have not gone in detail into that because this I just got from them. I just put this in the slide. Certainly, I'll try to find out more insight about. But in reality, what we are saying is that there are some stress corrosion cracking taking place, even though it may be wet H2S can create some problem, or if any carbonic acid kind of things coming about, whether that is causing some problem about. I don't know. We'll have to start looking at. See, one option is that the sour water which is coming in your cold separator. Can you take these and find out what kind of species which are present above? Because we always look at ammonium chloride or ammonium bisulfate, but we may not look at anything beyond. So maybe you'll have to start looking at what kind of, there is ionic chromatograph available in all your labs must be having, or your R&D at CPCL may have. Talk to them, find out what kind of anions and cations which are coming in this particular one, and try to see is there anything which we can try to. Because many times we have seen in overhead of CDU, of course, we do get some bromide, or we do get some HF or cyanide, etc. Is there anything of that kind creating this kind of a combination about? See, invariably what happens is that we all think that I'm supposed to, when the moment nitrogen is there, I'm supposed to get only ammonia. But if it forms in the form of cyanide for any reason, if it escapes, and that is causing some combination effect. I don't know. Or if any acid, which are light acids, are available. Because hydrocracking means you will always end up in some amount of acid can get formed. Carbon dioxide or carbon monoxide that is getting in the form of carbonic acid is creating this kind of problem. I don't know. There's a combination of chemicals are much worse than the individual chemical. We have seen this problem in our CD overhead. I'm just trying to take the analogy in the sense that CD overhead is, even though we measure only the ammonia, the chlorides, and the things like that, we don't even look at the what is the amount of acetic acid is there, or formic acid is there, or even some propionic acid. All these things are there. All this can come when we are doing an ionic chromatography. Maybe you try to take some call on this and see it about. I'm sure you'll get. And I have not got any inspection report. So if you have got any inspection report, share with us, and probably I can look through the inspection report. I can get back what is the thing. But normally, you see, inspection report guys will tell you that whether the corrosion is intergranular or it is any other stress related and things like that. Try to put it up. But they can look at the microstructure and find out how the boundary layer movement has taken place. Maybe they can give some idea to you. And plus, I do have some friends in corrosion. Maybe I can toss with them and then tell you about, as long as it's not confidential to your company. I don't want, because tomorrow Chevron should not come and say that, hey, why did you say about my unit to somebody else? Maybe you look in that manner to think about it. But certainly, since you are in Chennai and I'm also in Chennai only, maybe if needed one day we can meet also. That is also we can think through about. Certainly, we see. I'll put it this way that there is one refinery we are working for Korea now, because there the requirements have come. How I'm going to make my refinery run 6 years without any interruption. The Koreans are advanced. I'll put it about. Whereas we are struggling to get in more than 3 years, and nobody even talks about. See, we seem to be more complacent with what I did yesterday. That is not correct. I mean, at least a good engineer, you should never be happy with what I did yesterday. There are 1,000 more things to be done. How can I do it? And what is the way God is giving the power to make it happen? That way I look at it. Yeah. Certainly, I mean, I'm sure your problem can be also solvable. I'm sure something will be happening. And Chevron is also a very good company. I have seen they are refinery in Richmond, and their R&D center and all. Good people also to work with. I'm sure they will also guide you to better way to think.
Okay, sir. Thank you. Thank you, sir.
Welcome.
Sir, good afternoon. Sivashankaran from CPCL, sir. I am audible?
Yes, please go.
Sir, thanks, sir. Thank you very much for sharing your knowledge in this forum, sir. So I want to ask one question, sir, regarding processing of high tank crude in CDUs. Because most of the refineries in Indian scenario is designed for 0.5 ton max. Whether we can still source higher ton crude and then do it the blending, or any other methodology to compact high ton crude, sir. Can you share your...
We were also starting this Reliance 0.3, then 0.5. Then after some discussion with Shell, we said up to 0.65, there is no problem. Provided total sulfur in the crude is around 1.5 kind of. And our best processing, we have gone up to even 1.2 or 1.3 tan in the crude mix. We used to process all kind of crudes coming from the Middle East, not Middle East, but that Chad and so many places. And we used to add what is that called, from G, where we have found to be one of the best chemical as to inhibit this acid thing, and it has been doing very well, because we add right from the, I think to my knowledge, from heavy kerosene to the vacuum residue. In that zone, we keep adding in different locations in the refinery, right from the crude feed, then again at different product sites in pump around, or even the RCO, etc. We do it about, and HVG also we do it about. And I mean, to my knowledge, there is not even a single problem has been reported on account of high ton chemical what we are buying from now Suez. Earlier it was GE, and they got, I think, Predator, if I remember correctly. It's running very well. It's one of the best product I can think of. And see, you should be bold enough if you want. I mean, I can put you with some other fellows in Reliance. You can talk to them also, get yourself, or maybe your inspection guys can talk to Reliance people and then get the thing talk process. It's a wonderful chemical. It's running very well, and we will be getting more opportunity, because high ton crudes are good for what should I say? I mean, good for petrochemicals, of course, very good, but I'm not sure whether it is good for diesel. But if you are giving away in the diesel quality, you are supposed to make, let us say, 46 18 index, and if you're running around 50, maybe this can help you to avoid the quality giveaway also. No? It's worth it. I mean, I'll put it about. We used to process almost about 20-30% of crude like Doba, then I don't know what are some locale, like that. There are many crudes out there. Some of the crudes from Venezuela, they are also high ton crudes. They have been processing very successfully, no problem. Only one crude, I think, if I remember with Doba, only that has got some calcium naphtha in it, and you need to be a little more cautious if you're buying Doba. Remaining crude, you just blend the same way, you can do it. In a nutshell, look at calcium naphthanates if anything present the crude. Another one is that look at the what do you call it? I mean, blend you can always maintain up to 0.65. There is no problem for the chemistry to any chemical additive we added. You can go up to 1% without any problem. 0.8, 0.9 not very comfortably. And we don't allow any of the side stream having tan more than 1.5 mgkOH per gram. That way we look at it over. It's worth it. I mean, I'll put it above. I mean, you need to do some passivation and then post passivation also do it above. It's again a trade-off. I mean, because the chemical is very costly, and if you're processing on a continuous basis, it'll be still economical. But if you say I'm going to process on and off, then there is a problem because the chemical has to be more than the price at which you get the discount for the crude. But it's simple. I mean, it's no. I mean, I don't find any problem with the crude. I'll put it that way. But if calcium arsenate is there, you have to put some acid in the water, wash water going, because it creates some problem of calcium hydroxide, and that raises the pH in the brine. You can go even about 9.5, 10 and all. Then your disorder will not work, and there can be a big mess. We landed once in mess of this kind, but we learned by mistake. There are also some chemistries available. Suez we got for both. If you want to process Doba crude, they'll tell you how to process and get through it. Absolutely no problem.
Okay, sir. Thank you. Thank you. Thank you very much.
Yeah, sir, this is Dhanshekaran, 81 Chemical. Mr. Murthy Sab, it was really a wonderful presentation. Are you hearing, sir?
Yeah, very much.
Yeah, so thank you very much. And I have some couple of queries. I will quickly finish it. Okay. Actually, okay, I will come and discuss one query after the meeting because I think this is take time. Okay. Secondly, my query is you are mentioning some plasticizers which is going along with the diesel. I couldn't catch up that time.
It's a compound called 2,6-DMN. It is 2,6-dimethyl naphthalene.
2,6
naphthalene has got 10 positions because the two benzene rings, when they get fused, then you get 10 position you'll get above. So in that, what do you call it? I mean, the 2 position and 6 position, you have got a methyl. That's how it's called 2,6-dimethyl naphthalene. And it's a good material for making plasticizer. And today it is, I think its boiling point is around 260 or 270, I don't know whatever number it is. But to extract it out, you also get unwanted impurities coming along with it. So what is the best way to take it out? So that's what I told our friends. Can we do something? When Murthy or someone was there, and I told, why don't we just start looking at selectively what is the way to take it out? See, there are some adsorption techniques available. I told you about metal organic framework people are doing. There are some membranes available. These are some of the areas by which you can do some separation. So any separation other than distillation, it's may not be that much of energy very intensive. But distillation is being energy intensive, then your economics also need to be tracked very carefully. Particularly FCC running with high severity FCC. I mean, when I want to make propylene of more than 14-18% kind of, and that unit will have more of this material. Or even if I'm getting naphthalene, then after that, the naphthalene you can go for alkylation of fixing this 2-methyl into that, by which also you can make more. That means not necessarily that 2,6-DMN should be right at the level available in the LCO, but you can also take this naphthalenes and then like your alkylation you do. No? That is from benzene you make toluene by putting one methyl into it. Similar way you can do it to make. It's like that the technologies are available. It's a garden technology from Japanese and 1 or 2 fellows in the whole world is making it. And we tried, but for whatever reason, Reliance also did not pursue the thing. But it is one of the dream project of Mr. Professor M.M. Sharma. He has been repeatedly telling us to do it is worth it.
So thank you very much. And can you elaborate more on this, what you call, I just, okay. So I will come back to you, sir. Thank you very much. Bye.
You're welcome. Ankur?
Good afternoon, sir. This is Loganathan from Chennai Petroleum Corporation Limited.
Mr. Ankur?
Ankur, please unmute.
Yes, sir. Actually, I'm from BPCL Cochin Refinery Inspection Section. Sir, I have a couple of queries. One query is generally our wash water, which we are using in our all the process units. It is having pH close to 9.5 to 10.5 continuous for almost 1 or 2 years. So what's your view whether this will create whether this is creating issues in crude overhead and all if we are keeping that much basic wash water?
No, if wash water is added with ammonia, then there is no bottom pH will be on the higher side. But otherwise, typically wash water we recycle the boat water, no? So that boat water pH we maintain around 5.5 to 6.5. That's how the things go about. But some refiners, instead of adding ammonia separately, we add ammonia along with the wash water to do it about. See, I'll put it this way that if the pH is because of only ammonia, then there is no problem. But if the pH is because of some caustic or anything other kind, then there is an issue coming up. But see, certainly
because of this much, yes sir. Because of this much basic water.
No, you look at this. Don't look at only the iron which is getting picked up in the boat water, because it's a diluted material, because corrosion may be taking place in some corner. And ultimately, I'm collecting everything in the bulk form. So once in a while, you have to start looking at your permescence, because I have seen in HP, what is that, HMEL, they have installed almost about 10 or 12 permescence to understand what kind of corrosivity taking place in the overhead line and corrosion. Then you look at the inspection report of any of the exchanges which are there in the overhead system. If they are having some thinning, then there is an issue. We'll have to find out what is the way to overcome it. To be very honest, I mean, we lost, when we were in GE Suez, we lost many areas because of the overhead corrosion control. It's become very poor. In fact, we use one chemical thinking that the chemical is excellent from a corrosion protection point of view. But unfortunately, that chemical added more corrosion than the normal. That is where we found that the CFD and the injection quills and so many things are coming about in the picture. See, the one is ammonia. Ammonium forms ammonium chloride, which is also corrosive. But the ammonium chloride is readily soluble in the water. Whereas if you make any amine hydrochlorides, which that means if I use some utilizing amine and that is not getting solubilized properly, then that sticks to some of the surfaces. By the time it, the water comes and removes, the corrosion has started, or 100% corrosion can continue to happen. So we found several areas of this kind of pitting related corrosion because of some wrong chemicals. We can think that we thought is the right chemical in lab, it worked very well, but in the field it did not work at all because the field dynamics was not understood by the lab fellows. That's where we learned a hard way to think through.
Okay, Mr. Murthy, one more clarification on pet coke.
Yes.
Yeah, can you throw more light on it because of the high sulfur content? I was surprised a lot of pet coke is coming from refineries itself. Still, they try to buy the entire pet coke from energy point of view. Can you throw more light?
See, India is not having any problem of pet coke disposal because cement plants can take the pet coke because cement plants use coal. The coal has got high ash, whereas pet coke does not have ash more than maybe around 1.5%. But the best opportunity for the pet coke is, if at all you think, if any R&D efforts can be done about, and there again we did some work in Reliance, but somehow for whatever reason it didn't get through. See, pet coke will have nickel, and nickel is one of the hard recommended in the country for making many catalysts, etc. If someone can take out nickel, because nickel in the form of porphyrins, they say that nickel is sitting inside some asphalt and ring kind of. So if we can take out nickel bearing that coke, segregated by whatever manner, and then use it, recover it, that's the greatest achievement you can think about. So you have nickel, you have got vanadium also, if anybody is interested in vanadium, but the remaining like iron and all may not be of that grade. So if someone can remove these two out of the pet coke, or even out of the vacuum industry before it goes to the, coker unit, that's also the greatest achievement you can think about. That is the way, otherwise pet coke selling into the cement plant is ideal. But only problem can come maybe after 10, 15 years. I'm just looking at this because we have been doing one more work from the solid waste management. See, all these people are using the household. One is your bio related, which can be of kitchen waste. Any vegetables or any rice, whatever cooked material which I'm throwing into the dustbin. Another one is all this solid in terms of packing material or even any wrapping and coating and whatever things. And third is the medical waste in terms of diapers and so many things about. So what we have been trying to promote through some of our social network is that can we use this solid waste which can be having some caloric value, either cardboard or wooden or even this coconut shell and things like that, which can get into the cement plant, by which they can use it as a fuel. Because caloric value is less, maybe around 3,000, 4,000 kilocalories per kg as compared to coal means around 9,000 in that region, and pet coke maybe around still higher side. Or maybe coal maybe around 6,700, pet coke maybe around 9,000 calories. So there is a competition going to come tomorrow when I want to use this all this household waste into the fuel. At that time, petcoke price will further fall down. It's possible. So if I can create some better value from the petcoke, why not we do it above? And another one, if the FCC guys know who is working on FCC, the CSO, that's cyclic, what we call clarifier slurry oil. If you remove all the catalysts, probably that may be a good material for making needle coke. If we can make needle coke, that's one good advantage for the people can think about. Another one is that we make some carbon fiber. Like that, we have been trying some of the ideas we gave, but I don't know whether what level it is maturing level to think about. See, the reason is that one is that R&D fellows can always, the moment they find some setback, they start, their energy level drops substantially. So somewhere that time, either management has to tell or some of their friends have to tell, we'll make together, something like that to achieve it. See that all the patents, whatever we did so far in our Reliance, it all took almost about, for each patent, it took the life cycle of this patent from the time idea came to the time when the patent filed. I'm sure it's about 2 years or so. But the 2 years, somebody should not ask questions saying that, what did you do with the patent? You are sleeping on whether if you start, then you will be irritating the people. It's like, because the innovation can come anytime. You know? When you take bath, suddenly you get some bright idea, you can get it above. So it doesn't come with the fixed time cycle. No? It's not that every morning I get up and some new ideas come into. It's impossible to think through that. It takes time. I mean, one has to allow that to think. So some of the good companies now, I'm told that they also allow budgeting for the failures. Instead of doing the budgeting for human resource or salaries or travel and so on, you also make some budget for the failures. So I think people will be trying motivated to do it. See, we need to have a mind which is a little crazy. I mean, to a large extent, like what Japanese used to tell about. You have to be insane to become creative. But you cannot be insane forever. That's also equally important. We have to accept that as a creative thinking. We have to nurture them to think something more. Then you will find amazing ideas can come about. I'll put it that way. Because see, so the first thing is that just do as Indians, we can make a difference. So what is the way to take it forward? And second thing is that having done, what is the way I can make it work in the field? Both are equally important.
So thank you very much. And my personal thanks to the organizers for bringing in Mr. Murthy. One more request is it can be tailor-made. He has given a very broad picture of the entire crude and refinery. So that's all. I mean, it's really a wonderful thing. We want some tailor-made presentation for business opportunities on small scale or medium scale. I don't think small scale is practical, at least on the medium scale. Some other time when he's free. Thank you very much.
Now, my request to you is that, see, now that you've got the presentation copy and you send that your areas of interest, where you think that something can be done about. Because see, one side, if I write, I don't know what's needed for my customer. Because today we made, thanks to both Gopi and Sadasivan, I thought, okay, maybe a reliability area, maybe of great interest. Because if you ask my opinion, personal opinion, maybe we'll have to put a lot of efforts on the IoT. There's the Internet of Things, where the sensors can make a smart way to understand what is happening. So like today, just simple example I tell you. If you try any modern car, you'll always find the modern car tells you not only the fuel indication, it also tells you at what level at which you are getting the fuel consumption. It tells you that you are consuming 2 liter or 3 liter or 4 liter per 100 kilometers of travel. Or it tells you are consuming at 7. That automatically tells you either I've done my changing in the gear is something wrong, or maybe my tire pressure is not good. I mean, this kind of a proactiveness, if I'm able to give for some of the refineries, like amine foaming, this is one of the common things we see, or even foaming in the coke program, or even in FCC, where the things can something go right and wrong, or even the Slopex bed, which I told you. Is there any sensor which can pixelize this, capture if something is not going good, then automatically operator can do the changes to do it. Otherwise, operator is blind. See, we should be going away from the postmortem to the predictive or preventive type of things, for which what is the information I need about. Because laboratory fellow, if you tell him to do 10 times work, you'll get bored, and if he keeps on getting the data one less than one, he'll keep on reporting even when they become more than 2. He's also a human being. No? He can also make error. You say everything has been going good, so why should I do it about? Take a exam. I said, skip and do it about. But when you have a sensor, it will really work good. I look at that way to think through it. Maybe you'll have to put more efforts on the sensor. Can we make sensor which is workable with 99 point whatever percentage of uptime factor I can think about, with the accuracy within plus minus whatever repeatability of that instrument you can think about. Maybe, I mean, since that will be a even a simple pH meter, we have in Reliance in some place. but it doesn't work at all. So what is the reason why it is not working? You keep on giving your theory and I keep on saying it's not working. Then there's no merging. What is that which is causing this? What way we can do something different about it? Look through that.
Sir, this is Opiraju from Chennai Petroleum. So what's your experience of processing crude tank sludge in ECU units? Delayed coker.
Crude tank sludge, I think it's good for making micro-crystalline bags if somebody is interested in making it. And there are some parties who are taking it in, I think in Gujarat region we have found. Otherwise, we just, wash it with the LCO, life cycle oil, and then put it in the unit. Because since you've got a coker, there's no problem. See, everything is acceptable within certain limits. So my request is that if you want, you can take the crude tank sludge and find out how much percentage of LCO is needed to make it thoroughly mixing and doing it away, or even some heavy aromatic stream which is available from the paraxylene unit, any format unit you can think about, and then send it to the coker. The coker will take care of it. Then there is the best way to dispose. And if you want to make micro-crystalline, there is also pretty high cost material. People use it for making food grade because wax is sludge is nothing but full of wax and some asphaltics. So we have to find out that can I take out this wax material and then use it. Or if you are making bitumen, whether you can mix it with the bitumen. Think through that. You are making bitumen in your unit. Because sometimes the ductility or sometimes that penetration doesn't come very well the way you want. You take a call and see. Nothing harm in experimenting and seeing that we'll make some 3 or 4 options what I can think. Then you get the best option to do it. Don't think of conventional way to solve it, I'm saying. Because your refinery is unique. Certainly they've got many more opportunity to think about. I used to work with Basu, AS Basu, who is now SME. So we did some work on one more patent came in the same CLO. We did some splitting of CLO and find out that that has got one punch oil. It is good for naphtha cracker. CLO, if you take out top front end, the rear end, and you take out all the catalysts and front end, all unwanted lighter species. The middle cut is excellent for making the punch oil, which goes good for holding the asphaltings in your naphtha cracker plant. We made one patent in that process. Now that things do come about. See, look at all the low value products and what I can do. What is the way, and hydrogen management, what is the way I can do it? I think you'll have at least another 10 years of work without any problem. That's what my opinion is about. I wish all these inputs were given to us when we were in Indian World Days. Probably we would have done even better than what we did. Anyhow, better late than never, I'll put it that way.
Thank you, sir.
Yep.
Sir, it is way past 1:15, 1:20. We are close to 3 hours and still Mr. Murthy, sir, is going very strong, passionately replying everybody. And it was quite a feast to all of us today in terms of the wealth of knowledge share that you did on asset reliability and also inspiration about creativity and not to fear for any failure. Gopi is raising his hand, and after that, it will be very appropriate for inviting our friend Sadasivam to give a vote of thanks also formally. Over to Gopi.
Yeah. Sir, it was a fantastic speech, sir. Actually, we are lost for the right adjectives to express how much we enjoyed it. Few people can express their passion for the subject and profession so effectively. And you are one of them, Mr. Murthy. Thanks all for participating in the lively Sunday morning session. I hope all of us had some takeaways from it. Such interactive sessions would not be a success without you all. Hope you all enjoyed your Sunday and stay safe. Thank you once again. Over to Mr. Sadasivam.
Thank you, Govi, and thank you, Sadasivam, for helping me to know many of the good friends and past guys also, and plus new friends also. Thanks a lot for this opportunity. I'm sure we can work together and make a new India and put it that way.
Definitely, sir.
The oil will be there forever. That's not fair about.
Mr. Sadasivam.
Thank you.
Good afternoon, my engineering friends. It is nearly 3 hours, I think. The entire garment of petroleum industry has been exposed by my great Machan Murthy. Actually, I was quite astonished to hear the presentation today. What I know about Murthy was different, and what his presentation has given me a different part of his professional life. When I was in my schooling, he joined engineering and he was my role model. I particularly took interest in engineering because of his advice. But for God's sake, I did not choose chemical engineering.
You did a good thing.
I preferred civil engineering. I think if I chose chemical engineering, I think it was too boring for me. Actually, it is quite interesting for some people, but generally who are working in the social fabric also, chemical engineering is very tough and tiresome. But he could make a very good presentation, even that subject. I am quite astonished. I am very happy, and we really enjoyed it. But my two observations I want to make for my cousin. Shall I make my observation?
No, please. Learning is always continuous.
Okay. Your thought process is very, very, very fast. And similarly, your verbal expression is also very, very, very fast. Some people who are not linked to chemical engineering, we are making it was difficult to catch your words and catch the subject in it. So we have to be very, 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 very careful to follow your presentation. Suppose if we could make it a slow presentation, there are people from electrical, electronics, IT, civil, mechanical, and so on. So for future presentations, if we could make your presentation little bit slow, other faculties people may also able to observe your presentation in a full manner. Of course, we are able to catch your words. Your presentation was lucid, explanatory, everything was there. And this is my own observation. And for take home for people in the industries who are working was enormous. For youngsters who want to prefer some projects in petroleum industry, I think you can give some probable future medium scale industries, as Dhanasir has also meant. You can also suggest small, or if small is not possible, you can go and mention some medium scale industries for the future of youngsters. And very particularly, I am more interested and more worried if you could guide the government which has come to the elected government, new government, for the development of chemical industries, in very particular in Tamil Nadu, is more welcome. I will take you to the Chief Minister or the Minister concerned, Industrial Minister, who is our junior. We can do something for the development of chemical industries in Tamil Nadu. So I think you are the ablest, competent person to guide the future growth in chemical industries in Tamil Nadu. I'm very sure about it. It was a very nice presentation. I think I have suggested a right person for this forum. I really enjoyed with all my brother engineers today. Thanks all of the engineers who are presented today, and thank you the chief guest Murthy. We had a fantastic session today. Okay, thank you.
No, basically, see, what happens is that maybe that my habit is to speak fast, and this is one of the complaints I do get from many of my past presentations also. I've been trying my best to control it, but anyhow, maybe sometimes out of extra enthusiasm or out of what do you call it? I mean, what should I say? I don't know how to put it about more overjoy kind of. I need to go a little faster. Anyhow, but people have been able to catch me when they sit with me or for maybe half an hour or whatever. Certainly, it's a very good point, and certainly we'll do it again. And as regard to the second point, certainly I'll be also interested in doing many more for any chemical industry, particularly, for example, this our Tirupur, where the dye industries are plenty. We did a lot of work for dye industry when we were in GE. How to make this water what they're using. Is there any way by which the water crisis is going to be one of the largest one? And I do have some plans on the water. Maybe we can discuss offline, and we'll see what is the way we can take it further. Because at least I'll put about the bottom line is very simple. If you ask me, is that no one shall use groundwater throughout Tamil Nadu. What is the way we can do it? That's a task what is the way we can try to make it happen, both in coastal area as well as in the places where we can. You take any amount of river water, any amount of stored water, it's worth it. But groundwater, the moment I say from, let's say from 2030 onwards, no more groundwater use, then you will find amazing differences can come about. People say in the location where you live and the problem what the people are facing, if that can be translated, then you will find new solutions can come and then we can work with the common objective. Certainly, I mean, there is one area where we can put our thought process and do it, and because water is needed, water and oxygen is needed for as long as the humanity remains in the world. No? But if we can keep the groundwater for the future generation, that's the greatest achievement. We'll work on it, no problem. I'm with you, and I'll tell my brother-in-law also. Because all my chemistry knowledge have come from people like him and some of my own relatives who are chemistry professors. And once in a while, now it's nice to read, because earlier days when you're doing it, you are for scoring exam or scoring mark, etc. But now you enjoy the reading and doing it. Nice, thank you. Thanks, once again.
Can you do anything for improvement in cracker industry at Sivagasi?
Which industry?
Crackers.
Oh, that is totally inorganic. Anyhow, it's a very tough one. We will see that also. If any few lines, if you can send it across to me, then I'll pick on from there and do it about.
See, bound to grow manifold.
It's worth it. No, cracker industry is more of two things. What they say, one is that the pollution, another one that safety. Safety aspects have to be seen in a separate manner to see it about. And pollution aspect, we can start looking at what is the way when Chinese can do. There is a difference in terms of fireworks and the crackers. That's one concept which people keep on doing. Because fireworks means it is supposed to burst maybe about 100 meters or 200 meters above the sky. And crackers, what we are putting in the ground level. If you can stop the ground level cracker, then that's the greatest achievement. But how many people are interested in putting the firework? It has got its own haphazard, because so much of skyscraping buildings are there. I put something in after it should not go to somebody else's house and set a fire there. So you're right. I mean, that's one industry where people have to put a lot of efforts to make a difference. I agree with you.
Thank you.
Fantastic, sir. Thank you so much.
We will not hold you more, sir.
Yeah.
No problem. I take lunch at 2 o'clock. There's no problem. Nothing is.
Yes, sir.
இளநகை இருக்காரா அவர் நாப்தா இண்டஸ்ட்ரீஸ் பத்தியே யோசனை பண்ணிட்டே இருப்பாரு. இவரை விடக்கூடாது. அவரை
தனியா பேசுவோம். செல்வமூர்த்தியோட ஒரு சிட்டிங் தனியா வச்சுக்கலாம். அவர் எனக்கு ரொம்ப க்ளோஸ் ஃப்ரெண்டு தான்.
அப்படியா?
ஆமா.
இன்னைக்கு இப்ப நம்முடைய என்சிஆர்டி தமிழ் டிரான்ஸ்லேஷன்ல கூட இவர் ஒரு பார்ட் வைக்கிறாரு.
நம்ம தனியா பேசலாம் ஒரு நாள்.
சரி சரி. இளநகை
இருந்தீங்களா? தெரியவே இல்லை.
இருக்கேன்.
He's there right from the start, sir.
இருக்கேன் மூர்த்தி. வந்தோடனே உங்களை விஷ் பண்ணேன்.
Now, somehow I missed because somebody from Mathura they said about, but I thought somebody else.
நம்மெல்லாம் வயசாயிடுச்சு, அவங்க எல்லாம் யங்ஸ்டர்ஸ். நம்ம தனியா பேசலாம் மூர்த்தி, நிறைய பேசலாம்.
No, we are still younger only.
சார் வீடியோ ஆன் பண்ணுங்க சார். இல்லைனா சார்
இல்ல வீட்ல உட்கார்ந்து இருக்க தாடி எல்லாம் இருக்கு.
பரவாயில்ல சார்.
அப்படினா மோடி நினைச்சுக்கோங்க வேற என்ன.
எல்லாரும் உங்களையும் பார்ப்பாங்க சார்.
மூர்த்தியோட பேசிட்டு அப்புறம் நம்ம ஒரு ரெப்ரசன்டேஷன் கொடுக்கலாம் மினிஸ்ட்ரிக்கு.
கொடுக்கலாம் சார். We will have a separate meeting, sir.
Thank you.
Thank you.
Sengoden wanted to thank Mr. Murthy. Sengoden.
Yeah. Good afternoon, sir. I'm Sengoden from BPCL Cochin Refinery. Sir, your presentation was excellent.
Thank you.
Sir, one question I wanted to ask, but then since time was passing, this one the hydro treaters we are using in many areas mixed feed, in the sense light and heavy material like naphtha along with diesel or VGO and diesel we are hydro processing. So there is it actually energy efficient to do that?
You are feeding naphtha with the hydro treater, you are saying?
Yeah, naphtha and diesel as a combination we are using. Similarly, some point of time diesel along with VGO we are processing, hydro processing. So is it energy efficient?
No, if you ask me that already you are segregating the diesel, etc., in the crude unit or the vacuum unit. That's how the thing. Another one is that always in a liquid phase reaction there is no problem, but the moment there is a two phase getting formed in the reactor outlet, then you lose your hydrogen purity or the hydrogen partial pressure. This is again can impact your your life of the catalyst. So by and large, if you ask me, is that if my VGO hydrotreating unit, why I should have my diesel? But even if I'm producing, why I'm making the producer diesel, which is of not a great use about, because VGO should be made as sweet VGO, should go to FCC for making the cracking, for making whatever I need. I should not make diesel there. That's how I look at it. See, any hydrogen, even though we're all clubbing it under the what is called that chemical use of hydrogen, but if I'm making unwanted molecules in the VGO hydrotreater, be it naphtha or be it LPG or be it gas, I'm losing hydrogen in the process. Can I minimize it? That's what, even if you start looking at that, like SOR and UR, you make in SOR condition much less all these unwanted side reactions, whereas in UR you make everything. So that is where this, what do you call it, remember that we also look at the axial temperature difference in the radial difference in the reactors. If the radial delta T in the reactor bed is more than some 2 degrees centigrade, that means that some kind of a undue disturbance is taking place, and which can be leading to premature failing of the catalyst. So invariably, we have to start looking at is there any right mixing which I'm doing, or what is the way to take it forward. That's why the evaluated system, it has got, because it's always catalyst in the flowing conditions kind of. And that makes a better content and you're able to give a better product cost. So if someone can get the best of evaluated technology with a fixed bed reactor, what is the way I can get the difference? So maybe we'll have to talk to your R&D fellows to find out what is it happening, how I can get the things out of it. You see, the moment I reduce hydrogen instead of 1% or 1.5%, what I'm using today, if I can come down to, let's say, 0.7, so imagine how much of energy you have saved for the company.
Yeah.
That itself helps you to your reducing CO2 and all, because hydrogen is coming from your, whether from methane or ethane or from naphtha. No? Why should I do all the things alone?
Yeah.
And what is CO2 I'm generating? I look at that way. But unfortunately, this question I've been posing to our R&D people or even the hydrotreater fellows, and they said, no, this is not side reaction, you cannot stop it. Then there is where we started looking at the thermodynamic equilibrium and the kinetic controlled reactions. What is the way we should do it? See, the hydrotreaters have, over a period of time, really they have improved a lot. I mean, in terms of oil to gas ratio or in terms of hydrogen partial pressure, etc. What we thought should be very high, but nowadays is much less.
Yeah.
See, I look at this way that not only that, some kind of integration between the units which are producing hydrogen with the hydrogen plant, that's a happiness. See, like when we started Haldia Refinery, there was no hydrogen plant separately. All hydrogen used to come from the reformer, because we used to make gasoline, means you produce no hydrogen in the process, because you are converting paraffins or naphthens to aromatics. So you generate hydrogen. That hydrogen was used for hydrotreating. But now that's not the case. We are always using some excess hydrogen also to bring in the system. Why I'm doing it? Can I minimize it? Can I avoid it? What is the way to take it forward?
Yeah. Okay. Thank you, sir. Thanks a lot. We'll meet sometime when you're coming to questions.
Sure, sir.
Thanks a lot.
Thank you.
இன்னொரு தீவிர ரசிகன் கேட்டாரு.
உங்க வாய்ஸ் கேட்கல சசிவ்.
சுந்தரம் தாய்லாந்துல இருந்து இன்னொரு ரசிகர். இஸ் a great fan of மூர்த்தி.
வணக்கங்க மூர்த்தி.
சுந்தர். Nice talking to you. Nice seeing you also.
ஆமா. நல்லா இருக்கேங்க. நீங்க எப்படி இருக்கீங்க? ரொம்ப நாள் ஆச்சு பார்த்து.
நான் பார்த்தேன். லாஸ்ட் டைம் we met மெட்ராஸ்ல பார்த்தா, அப்புறம் வந்து விருதுல வந்தீங்களா? அது
கரெக்ட். அதுக்கப்புறம் வரல. அதுக்கப்புறம் சென்னை.
நைஸ்
நல்லா இருந்துச்சு இன்னைக்கு பேச்சு. உங்க பேச்சு வெரி யூஸ்ஃபுல். ஆல் அப்டேட்டட் interesting things.
I think it's scared after seeing you and Elnage and all the people. There are stalwarts. In front of stalwarts to speak, I am also a bit scared of it.
சுந்தர் 3 மணி நேரமா கேட்டுக்கிட்டே இருக்கியப்பா பொறுமையா. உனக்கு
நானும் அவர் மாதிரி
தெரியுது. இல்ல அவருடைய பேச்சு அந்த மாதிரி இருந்துச்சு.
கெமிக்கல் இன்ஜினியரிங்னால உங்களுக்கு, நீங்க சிவில்ங்கனால உங்களுக்கு சம்பந்தம் இல்லாத கேட்கறது கொஞ்சம் கஷ்டம்.
எங்களுக்கும் அது நல்லா தான் இருந்துச்சு. பட் நீ பயங்கரமான கோடிக்கணக்கா புரட்டுற ஆளாச்சு, நீ வந்து 3 மணி நேரம் ஒரு சப்ஜெக்ட் கேட்டுக்கிட்டே இருந்திருக்கே அப்படின்னு பார்த்தேன் நான்.
அது சரி சண்டேங்க அன்னைக்கு சண்டே என்ன போய் புரட்டேன். ஓகே,
நீங்க ரொம்ப சந்தோஷமா இருந்துச்சு. தேங்க்ஸ் திருப்பியும் சொல்லணும் மூர்த்தி பச்சானுக்கு ரொம்ப நன்றி.
Okay, welcome, sir.
He's got a fan base across the globe. It's very nice, sir.
Right.
Thank you so much, sir.
மீட்டிங் இருக்கா தாரிக்கு?
இல்ல சார், இன்னைக்கு இல்ல சார். 1:30 ஆயிடுச்சு சார். 1:40 ஆயிடுச்சு சார்.
1:30 ஆயிடுச்சு.
சாப்பிட போலாமா?
நம்ம 2 minutes பேசிட்டு போயிடலாம், வேற ஒண்ணும் இல்ல. Right, sir. Thank you once again. Thank you all for being with us.
நம்ம committee members இளங்கோவன் சார் இருக்காங்க. You can say hello.
இளங்கோவன் சார், ஸ்ரீகுமார் சார் சொல்லிட்டாரு, அறிவுராஜா, வைத்தி.
இளங்கோவன் சார் மியூட்ல இருக்கீங்க.
Can I sign off?
So one second, just 1 minute, just 1 minute, sir. 1 minute, sir. One last minute.
இளங்கோவன் சார் is from Coimbatore.
நான் 82 batch சிவில்ங்க, ரிட்டையர்ட் சீஃப் இன்ஜினியர் ஃப்ரம் தமிழ்நாடு வாட்டர் சப்ளை அண்ட் ட்ரைனேஜ் போர்ட். வெரி நைஸ் பிரசன்டேஷன். ஐ திங்க் நிறைய பேருக்கு நல்ல யூஸ்ஃபுல்லா இருந்ததுன்னு நினைக்கிறேன் இன்னைக்கு. அஃப்கோர்ஸ் தோ ஐ எம் நாட் இன் த ஃபீல்ட், பட் ஐ என்ஜாய்ட். தேங்க்யூ.
Sir, we'll let you go, sir. Thank you very much.
Yes, sir, we'll let you go, sir. Thank you very much, sir. Vichu.
Thank you.